Hi, welcome back. So the next topic which we are going to talk about is the Terraform expressions. Terraform expressions help us to improve the quality of our code, to make our code more powerful. So let's take an example. I wanted to deploy 5 resource groups. So now I can write the resource block 5 times to deploy those resource group. Or I can use the grouping as a Terraform expression to just write one resource block and iterate it over again and deploy the 5 resource group. Or let's take an example. I do have a code to deploy the virtual machine. And then there is a variable called operating system. And if the operating system variable value is Windows, then the Windows resource block or virtual machine block of a Windows machine should be executed. Or if the virtual machine or operating system is assigned to Linux, then the Linux related resource block should be executed and virtual machine of the Linux should be created, not the Windows, and Windows should be escaped. So with the help of the conditional expressions, we can do this kind of a task. And on top of that, we do have the different functions in the Terraform expressions, which we can use to perform a different values or different tasks. Then we do have a dynamic block. We do have the provisional null resources. So all these sections or topics comes under the Terraform expression, which we are going to discuss in this particular topic. So let's have a look. So in Terraform expression, we are going to talk about the functions. We are going to talk about the conditional expressions like if-else condition. Then we are going to talk about the type of groupings in Terraform. There are 3 types of grouping, which we are going to discuss in the grouping in Terraform. And we'll see like where and why we are using this grouping and the other one. Then we are going to talk about the dynamic block. That is also very important in Terraform. And it helps us a lot in the real-time scenarios. So we are going to discuss about the dynamic blocks. We are going to talk about the provisioner, like how provisioner help us to run the different PowerShell or the shell script with the Terraform itself. And there are different provisioner which we can use to execute the script locally where we are running the code, or remotely, like if I'm creating a virtual machine, then I want that specific PowerShell script should be executed to my virtual machine. That is also we can do with the help of the provisioner. And then we are going to see what is the null resource and why we are using the null resource. So this all topics comes under the Terraform expression, which we are going to discuss about. So let's start with the Terraform functions. In function, basically there are a lot of functions available in Terraform, but I just pick a handful of function to discuss because I can't explain each and every function, and you can always refer the Terraform documentation for that. But I pick a few most useful functions which, as per my experience with the Terraform so far, which we are using in our real-time environment. So let's discuss about those functions. The first one is the timestamp. So we do have a timestamp function in the Terraform to get the current time. And why we are using it, I'll show you an example. So first, let's have a look. I'm taking an output block to see what is the output of this timestamp function. To write the function, similar to the other languages, the function is always come with the timestamp and the braces. Okay, the normal bracket, which we do have circular brackets. And if I run the Terraform plan or Terraform apply command, I'll see the changes to output will be the known after apply. This is known after apply because it will take the exact time of the apply. So the timestamp will take time is equal to the exact time and in a specific format. So there will be a year, month, date, and then there will be a time in a 24 hours format. So you can see with the help of the timestamp, we can take the existing time. And I'll tell you one very useful case of this timestamp function. So let's assume I wanted to create a resource group, and I wanted to make sure that whenever I'm creating this resource group, there should be a tag. There should be a tag which should be included as a created on, because Azure doesn't provide you the information when this resource was created. Actually, it does, but it does provide you with the activity log, and then you have to find the activity log for that particular resource group when it was created. And if you are not configured the log analytics workspace, then after 90 days, that information will be gone. You will not be able to find when this resource was created. So when in my environment, whenever I'm creating any resource, I'm always tagging it with the created on and using the timestamp function to make sure it will have the time of the when the resource was created. So timestamp we can use to tag or we can also use in a different complex way when you are working on and you see the scenario like I need a time here or there, then you can use the timestamp function to get the current time. The next one is the try. Try is again very important one. So let's assume there is a local variable called subnets, and I do have the value for subnet 1 and the subnet 2. It's a map, right? So I do have value for the subnet 1 and subnet 2. Now let's see, I'm writing output for subnet local.subnet.subnet 1, and the subnet 1 is there, so output would be the value of the subnet 1. But what if I'm writing it instead of the subnet 1, I'm using the subnet 3. By looking at the code, I do know there is no subnet 3. But when you are going to work on the Terraform, there are some output which you don't know if it would be there or not. So how we are going to handle this kind of a scenario? So let's assume that we are trying to get the output of the subnet 3, but we don't know if subnet 3 is there or not. What would happen? So if I run the Terraform plan, there will be a error that subnet 3 is not there. Or the local.subnet is object with just 2 attributes and subnet 3 is not one of the attribute. In this scenario, what we can do is we can handle it. We just wanted to make sure that there should not be error. There should not be any error. And I want, like, if subnet 3 is not there, then use the subnet 1. Then what I can do is I can use the try is a function, and I can write try local.subnet.subnet 3, comma, if this value is not there, then use the subnet 1. So try this. If it is not available, if you are getting error for this particular value, then try that. So with the help of the try value, we can check if this is there, or if it is not generating error, then give the value of the subnet 3. If it is generating error, if it is not there, then use the subnet 1. Now if I run the Terraform plan command, you will see I'll get the value of the subnet 1, because subnet 3 is not there. So it tried the subnet 3 was not there, so it has used the subnet 1 as a value. So with the help of the try, we can do, if this is not there, then use that, or we can replace this kind of a scenario. We can use these values or handle the error for our Terraform code. The next one is the Cohese. Cohese is again one of the very useful one. So let's assume I do have some scenario. I'm not talking about this one, but let's assume I do have some scenario and I don't know if the output of a specific expression or a specific resource block or something like that, I don't know if the output would be the null or not, or if there are multiple value where the few values could be null and few values have the value. With the help of the Cohese, I can make sure that only the value which is not null taking into the consideration. So in this scenario, I do have a local.subnets variable where I do have the subnet 1, subnet 2, and subnet 3. And I have assigned null to subnet 1 and subnet 2. But there is a value for the subnet 3. And I'm using the Cohese. Now, what Cohese will do, Cohese will check the subnet 1 value. If it is null, then it will skip. It will not generate the output for the subnet 1. And then it will check for the next one, subnet 2. If the value of the subnet 2 is there, then it will consider the subnet 2. If it is also null, then it will check for the subnet 3. And if there is a value, then it will consider the non-null value. So Cohese can check if the value is null, then it will skip it, and it will only taking into the consideration for the value which is not null. So if I do the Terraform plan now, I'll be able to see it has considered the subnet 3. Now the next one is merge. Let's assume I do have two map variable. We already talked about the type map variable type, and we know in the map we do have the key values. So if I have like a two map and I wanted to merge it with the one, so I can use the merge function to merge two map variable. Okay, this is specifically for the map variable only. So I do have one map variable called subnets, and I have introduced the new one, that is subnet 4, which is in a different variable, and I just wanted to merge this two map variable. So what I can do is I can use the merge, and I can use the local.subnets comma local.subnets underscore new, and then I run the Terraform plan command. As soon as I run the Terraform plan command, I can see the output is merged map with all four subnets into it. So with the help of the merge, we can merge two map variable. There is another one called lookup. Lookup is basically to check if there is any specific key available in a map variable. This is again for the map variable. So with the help of the lookup, I can find the value. So again, now I know the locate.subnets has the subnet 1, 2, 3. But in case if we are generating the a map with some conditional expression like a for loop or something like that, and we don't know if that particular variable value is there or not. So we can use the lookup to find the key of a map variable. And when I say key, that means subnet 1, 2, and 3. So with the help of the lookup, we can find a specific value from your map variable. So lookup bracket local.subnets. I wanted to find inside the local.subnets, and what I wanted to find subnet 3. So it will generate the output of the subnet 3 only. So it will show you the value of subnet 3. So with the help of it's just a filtering. If you want to do the filtering, you want to find something from a map variable, then you can do with the help of the lookup. So these are all about the Terraform functions, and we do have many more. You can always follow the Terraform documentation for the different kind of a function, and you can see like what function is fitting into your requirement. But these are the most useful ones, so I have described them and how we are using the functions. When we are going to write the Terraform configuration code, we are definitely going to use this kind of a function. So this is all about the Terraform functions. Now let's talk about the conditional expressions. Conditional expressions is basically a if else condition. So if you have used any other programming language or the scripting language, you know what we could do with the if else condition. So we can check few values, and based on that, like if the value is true, then perform this task. If not, then perform this task. This is something we can do with the conditional expression as well in the Terraform. We can do this conditional expression or use this conditional expressions with the variable. We can use with the resource block arguments, and we can perform different tasks based on the value which we are getting as an input. And if the value is true, then do that. If the value is false, then do that. This is what we can do with the help of the conditional expressions. So let's have a look. I'll show you how to write the conditional expression in Terraform and show you a simple example so you know how it works in the Terraform. But in the lab, we are going to discuss more precisely with the resource block and see some useful use cases, what we can do with the conditional expressions. But here, just let's understand how it works. In Terraform, we write a condition. We use a question mark sign to identify if the condition is true or not. Okay, so condition, then question mark to identify or to evaluate if the condition is true, then give the output of a true value or perform this particular true value task. If not, then we are using the colon sign. Colon is if the value is not true. So condition question mark value is true, then the generate the output of true value. Colon else, yeah, if not, then do the false value. This is what we can do with the conditional expression and use the conditional expression in the Terraform, and based on the condition, evaluate with the question mark, generate the true value. If false, then colon and the false value. So let's have an example. I do have a local variable a is equal to 100, b is equal to 200, c is equal to 200, and that's why I told you that I'm going to take a simple example, not a resource block or some fancy, because first let's understand how we write the conditional expression and the format of the conditional expression, and then in the lab environment I'll explain it more how we use it with the resource block and what are the different scenarios. And going forward also we are going to see how we can use the conditional expression in a different scenarios. But for now, let's have a look with a simple example that we do have a local variable called abc. A is equal to 100, b is equal to 200, c is equal to 200 again. Now there is an output block called fact check, and the value is equal to local.a is equal to local.b. This is the condition, and in the Terraform we are using double equal to sign to compare the value. So local.a compare with the local.b if it is equal to or not. You can also use the exclamation sign with equal to check not equal to. You can use the greater than, less than, and the normal expressions which we generally have in other languages as well. But here I just wanted to compare if the local.a is equal to local.b or not. And then, as I have mentioned, use the question mark sign to evaluate it. If true, then it should be hooray. And if false, then it should be oh no. So that is what the output is going to be generated, or the value of your output would be hooray if it is true, the condition is true, if A is equal to B, which we can see it's not. Of course, 100 is not equal to 200. So my expectation would be it should generate the oh no. So let's have a look. This is our condition. This is our if true, then return this value. If false, then return this value. And there is a fact check too, where local.b is equal to local c, which we know that local.b and c is equal to. So now let's have a look, and let me just explain it again. The condition, question mark, if true, then return this value, explanation, if false, then return this value. So this is how we write the conditional expression. Let's have a look. If I generate the Terraform plan, the fact check one is false condition because A is not equal to B. So it has written the value oh no. And fact check 2, B is equal to C. We know B is equal to C because both are the 200. So now the value would be okay. So this is how we use the conditional expression in a Terraform. So this was a very short and simple example, a very basic example how to write the Terraform condition or if else condition in a Terraform. And we can use it in a multiple way, in a resource block, in a variable, in a arguments, in a output, wherever we want. So let's have a look in a practical way how the conditional expressions work, and I'll show you some examples, some useful use cases in a real-time environment, and then we are going to talk about more about the conditional expressions. So let's have a look. So we talked about the conditional expression in this session. Now let me show you one of the good example which we could use in our project for the conditional expression. We talked about the tagging, right? And we know that we have one more tag called sensitivity, which we would like to add. And the sensitivity is based on the work environment. So if the environment is prod, then the sensitivity would be the high. And if the environment is test, then it will be medium. And for any other environment like sandbox, UAT, and whatever we are going to create, the sensitivity would be the low. Now, either I can define that value in the variable and pass every time, but I know like I'm already passing the environment name, and this value is depend on the environment name itself. What I can do here is I can use the conditional expression to define the value of the sensitivity tag based on the environment, right? Like I showed you the example that variable value can dynamically be changed based on the another variable using the conditional expression, right? It's a if and else conditions which we generally have with every other language. So let's see how we can use it into our environment. The tag I want is the sensitivity, and the value of the sensitivity will be defined based on the value of the var.environment. So now I have to use the conditional expression if condition. So first if condition would be the if var.environment is equal to prod, then. So when we are using conditional expression, question mark sign is representing the then. Like if this condition is met, then what would happen? Okay, if this condition is met, then what would happen? So var.environment is equal to prod, then the value of sensitivity should be high. But that is not the only case we have. If var.environment is test, then the value of sensitivity should be medium. So we see the condition var.environment is equal to prod, then it should be high. But we do have furthermore condition called else, right? If is always coming with the else. If the condition is met, then it should high. If not, then check again the var.environment is equal to test, right? If var.environment is high, var.environment is prod, then it should be high. If var.environment is not prod, that is something we are going to represent by the colon, like the else condition. If it is not high, then colon, then check again var.environment condition is equal to test. Is var.environment is test? If it is not prod, then is it test? If yes, then again question mark, and the sensitivity should be medium, right? If var.environment is equal to prod, then should be high. Otherwise, check again. Is it test? If yes, then it should be medium. If it is not test, not prod, then for else, for everything else, it should be low. Okay. So if var.environment is equal to prod, then high, the sensitivity value should be high. Else, check again var.environment is equal to test. If yes, then medium. Else, for anything else, it should be low. Okay, so this is how we are going to configure the conditional expression here with the sensitivity. So we don't have to define another variable for the sensitivity and take as an input, because we know the sensitivity is depends on the environment name. So we can have this dynamic condition or conditional expression here, like if the environment is prod, then it should be high. If not the prod, then check. If it is test, then medium. If it is test, then use the medium. If not, then use the, or if it is not medium or high, or if it is not prod and test, then for anything else it should be low. So for anything else it should be low. Or if we have another condition, like let's assume for the UAT, so for UAT it should be low, so I can use the var dot environment is equal to UAT, then should be low. And if it is not var dot environment is equal to UAT, then it should be very low, something like that. So that is also we can configure, but yeah, in our case, it should be high for the prod, medium for the test, and for any other environment, it should be low. So now let's try. We have added this new one. We already know in the terraform.tf was the environment is equal to test. Okay, now I'm going to run the terraform plan command to check what would be the sensitivity value for my tagging. Because I am already using this local.tags in all of my resources in the resource group and the virtual network or wherever. If not using, then I can use it here. But for now, I'm using it into the resource group. So let's take a look. I made a little bit changes into the code. I just removed the prod references for now because it will be a little bit complicated when I'm going to run the command. So I just removed the prod references, but I already explained you in the last section about the file structure that how we are going to deploy the prod environment. But so far this environment or this spoke is just for the test. Okay, I can see the sensitivity is medium because my environment is test. Okay, that's nice. Now I can check another one with changing the environment with prod and see if it is making the prod or not. But the problem with changing this variable is it will change all of the others variable as well. And then my plan will be very complex, very confusing. So what I'm going to do is I'm just wanted to check like if my condition is working or not. So I don't have to do the plan or the apply again to just check it. What I can do is there is one more command which we are going to talk about called Terraform console. This command is basically giving you a CLI console, a command line console, where you can run or you can run few commands related to the Terraform, like checking the functions, checking the value of the variables, if it is selecting dynamically or something like that. So I'm going to explain it in the advanced command, but I thought to use it here to show you, like based on the environment variable, what would be the local.tags value. Okay, so I'm running this Terraform console command and I got this prompt. Okay, now what I'm going to do is I wanted to check the value of the local.tags, which is going to be applied to my resource group. Let's run. Okay, now it looks good because I have changed the Terraform TFVAS with the prod, and I can see the environment is going to be prod, and based on the environment, the sensitivity will be the high. Test we already saw by running the Terraform plan, and prod we can see it is high. If we are changing it furthermore, like sandbox, let's see what would be the value for the local.txt. I think I'll have to run the Terraform command again console, because as soon as you are running the you are saving the file and running the Terraform console, then it will always take the changes which was last saved. So I have replaced the environment again, saved it, and using the Terraform console command again and run the local.txt. And now I can see the sandbox is go. So I have configured the condition. For prod it should be high, for test it should be medium, and for any other it should be low. So for sandbox it is low. Now let's check for the UAT, because we have configured for everything else. Everything else, then prod and test should be low. So sandbox is indeed low. Now let's check for the UAT as well, just to confirm if the else condition is working fine or not. I have changed it, save the file, and run the Terraform console again and check the value for the local.txt. So that is also a good way to check your changes using the Terraform console command. Okay, for UAT also it is go. That means my condition is working fine. If environment is prod, then should be high. For test, it should be medium, and for anything else, it should be go. So that's all about the conditional expression, and this is how we are using. I'm going to show you more examples of the conditional expression, how we are combining it with the looping and other ways like a count and all. That is very useful, and in the production we are always using it. So we are going to talk about it. Anyways, if you have any question related to the conditional expression so far, you can put post your comment into the video, and I'll try to answer it as soon as possible. Hope you enjoyed this session, and I'll see you in the next one. Now let's talk about grouping in Terraform, and this is very important. I know I'm keep saying for every other topic that this is important and that is important, but for grouping, I am very sure this is very important. When you're going to work in a production environment with the production Terraform code, you're definitely going to use one of the grouping way. And similar to any other programming language, we have multiple way to do the grouping in Terraform. This is what we are going to discuss in this section. And I believe this is one of the longest topic I do have in my course. And I have considered every possible scenario to explain it and how we can merge it with the conditional expression, how we can use a different way to do the grouping, and how we can perform a complex calculation and complex evaluation in your Terraform code with the help of the grouping. So let's have a look. We do have, as I have mentioned, that we do have multiple way to do grouping in Terraform. So let's talk about the types of loop. We do have count, we do have for each, and we have for. I'll explain each and every one with all the example where we are using and how we are using it. So let's start with the count group. Let's assume I have to deploy three resource groups, RG1, RG2, and RG3. So I can just simply write the resource group block to deploy resource 1, 2, and 3, resource group 1, 2, and 3. That is the one way. That is the way without the grouping. Now let's assume I have to deploy 100, then I have to copy 100 times, right? Instead of doing that, what I could do is I can use the count group. I can use just one resource block with the count group to deploy all three resource groups. So let's see how we can do with the help of the count group. We can iterate the resource group block again and again using just one resource block to deploy three resource groups. So let's see. I'll have to write in a similar way the resource block. What I'll have to do is I'll have to add a new meta argument called count. And I'll also have to change the name of the resource block, or if I don't want, I can just keep RG1, but RG1 doesn't make sense because only one resource block is going to create all three resource group. So RG1 doesn't make sense. So I'm going to use the RGs, and I'll use count as a meta argument. And how many resources I want? I want three. So count should always be assigned with a number, right? Because we wanted to iterate on the basis of this count. So it should always be a number. So count is equal to 3. Okay. Now we know that we get the count is equal to 3, but it will iterate. Of course, it will iterate because we are going to use this count 3. So the problem would be the resource group name would be the same always. The resource group 1, 1, 1, and it will not work because we can't create the same resource group again and again. So what I can do is instead of using the same resource group name, I want it should be iterate with the count itself. So on the one count, it should be 1, on the second count, it should be 2, and on the third count, it should be 3. The name should be 1, 2, 3 as well with the resource group. So what I can do in that case, I can just remove the 1, and instead of that, I can use count.index. This is a special argument we can use with the count. That means count.index means with every iteration, this value is going to be replaced. So what I want is I want resource group underscore on the very first iteration. It should take the first iteration like 1 and then 2 and then 3. So now let's have a look with per count index, and with this configuration, if I'm using the count is equal to 3 in my resource block, what would be the output? I run the Terraform plan command and I can see there are 3 iterations. The first iteration is resource group, and the name of the resource group is resource group underscore 0. Then the second iteration identifier, because now we are using the count, so the identifier, the reference identifier like Azure RM resource group dot RGs, will have the iteration as well. So the iteration would be 0, 1, and then the third iteration would be the 3. Why it took like this? Because the iteration in Terraform works with 0 or start with 0. So when we are writing the count, it is start with 0. It doesn't start with the 1. So that's why it took resource group underscore 0 as a name, because we are iterating it based on the iteration. And if I'm matching with my desired requirement, it doesn't make sense, right? Because I want 1, 2, 3. I don't want 0, 1, 2. And this is not what my requirement is. So in that case, what I can do is I can just simply add +1 next to my count.index. That means the very first iteration would be 0, but the name should be 1, right? Because this is my requirement. If your requirement is 0, 1, 2 in the name of the resource group, that is fine. Then you don't have to add the +1 with every count.index. So with the first count.index, the value would be the count.index value would be 0, +1 making it 1. Second iteration, it will be 1, +1 making it 2. And then third iteration, it would be 2 +1 making it 3. And if I do the Terraform plan now, I can see the resource group name is RG1, resource group 1, resource group 2, and resource group 3. Though my identifier is still with 0, 1, and 2. And that is something we can't change, because based on the iteration, based on the count, the identifier name is getting stored in our Terraform state file. So this is how we are writing a count group, or we are using a count group with our resource block. So what we have to do is we have to use a meta argument called count is equal to 3. That is the first thing. Second thing, we can change the resource block name, because if I'm using just one resource block to deploy 3 resources, so it doesn't make sense to use the RG1 as my resource block name. So what I can do is I can change the resource block name with RGs, because there are multiple RG resource groups. Then I'll use the meta argument called count is equal to 3. Two things I have done. And third thing, because the name was resource group 1, and if I just iterate with the same name, it is not going to work. The plan might work, but the apply will not, because you can't deploy the same resource group name again and again. And this is not what my requirement is as well. So what I have to do is I have to use the count.index with my interpolation, and with +1 I can make sure that it start with the 1. The name itself, the resource group name, it start with the 1. So this is how I can use the count and to deploy the resource group. Now let's have a look to the references, how we are going to use this reference when we are deploy the resources, because we saw the references in the output. The identifier is Azure RM resource group dot rg, and in the braces, on the square braces, it was 0. So now I wanted to deploy the network security group. How I'm going to do it? So I'm using this provider resource type dot and the block name. Okay. And if I use the dot name, that means the name of the resource group. Will it work? Let's have a look. If I run the Terraform plan command, what it will say, or what it will error out, because Azure RM resource RG has counted, its attributes must be accessed on specific instances. Because now the network security resource block doesn't know in which resource group it should be created. Because with my resource block, I'm creating three resource groups. So now it doesn't know if I should go into the resource group 1, 2, or 3. So we have to specify it. And the way to specify is we can either use the count.index, but then again we have to use the count in NSG. But in my case, I don't want it to use. I just wanted to deploy NSG1 in the resource group 1. So what I can do is I can just simply move dot name a little bit aside, and I can use 0, because I know the 0 iteration is generating a resource group 1. So this is how I can do. And if I run the Terraform plan command now, I can see the resource group 1 was taken into the consideration. This is how we can do it. But let's assume if we wanted to deploy 3 NSGs, and each NSG should go into the respective RG, respective resource group. Then what I can do is I can use the count is equal to 3 in the NSG as well. And at the time of the reference, I can use count.index. And in the name as well, I can use the count.index +1. And in the resource group reference, I can use the count.index, not count.index +1, because attributes value or identifier value is start with the 0. Though my name is start with the +1 or the resource group 1, but the attribute value is start with the 0 itself. So I'll have to use the count.index in the resource group name but the name would be the count.index plus 1, and I'll use the meta argument count is equal to 3 in the NSG as well. I'll suggest to do this example by your own and see how it works. We wanted to deploy 3 NSG 1, 2, and 3, and they should go to the resource group 1, resource group 2, and resource group 3 respectively. So this is how we can use the count meta argument or count Terraform expression to deploy multiple resources using only one resource block. Now, let's have a look to the conditional expression with count group. So far we have a look like how count group works, and we know how the conditional expression work, which we already talked about. We saw some examples. Now let's combine both of them and see how it works. And this is the production related code which we are also using. So let's have a look how we can use the conditional expressions with the count group. So let's assume I do have a resource group. I'm creating a resource group, and I wanted to check if there is a variable called I want a new RG, and the type is Boolean. And when I say Boolean, that means it will be either true and the false. The value of the I want new RG would be either the true or false. So if I want new RG value is true, then only the resource group 1 should be created. Otherwise, it should not be created. This is what I want. And that is something you are going to use in your production environment for sure. We are using it based on the particular variable assignment, based on the input, the resource block behavior is going to be changed. And with the help of the count group and the conditional expression, we can use it. If you remember, I have explained an example like if the variable value operating system variable is Windows, then only the Windows resource block should be executed and Linux should be escaped. How we are making it escape? So with the help of this count group and the conditional expression, we can do that. So let's have a look. What I can do is I can use the count, and the value of the count should be I want new RG. So it's a combination of your count group and the conditional expression if you have look into it. So count is equal to what should be the count. So count can be either 1, 0, 2, 3, 4, 5, whatever the number we want, right? We already saw it. We used 3 in our last example. But now what I want is I want to define the value of the count based on the condition. So if I want new RG variable is true, then what it should return? It should return 1. That means count is equal to 1. That means one resource group should be created, right? But if I want new RG value is false, then what it will return? It will return 0. That means this resource group will not be created. It will be skipped. Because if count is equal to 0, that means it should not be executed. That particular resource block should not be executed. Simple. If we have one count, then one time iterate. If we have two count, two time iterate. If we have zero count, doesn't iterate. That means that resource block will not be executed at all. So let's have a look. If I run the Terraform plan command, it will ask me the value of I want new RG. If I set it true, then the resource group will be created. Only one resource group because I have condition, it should return only 1 and 0. And based on the I want new RG value. So if it is true, then it will create one resource group. But if it is false, I want new RG value is false, then no infrastructure changes are there because nothing will be deployed. This resource block will be escaped. So with this kind of a combination with count group, conditional express, we can perform a complex task and evaluate a different values, and based on that we can perform if this resource should be created or not, or if it is created then where it should be created, how many times it should be created. With the help of the conditional expression and the combination with the count group, we can perform multiple things on the Terraform code. So this is all about the count group. Now let's have a look in a practical way how we can use the count group, and we are gonna discuss more about it in a practical way in a production scenario where we are using the count group. Okay, so let's have a look. Hi. So we talked about the conditional expression with the count group. I already explained what is the count group and how we are using it to generate or to create the multiple resources using just one resource block. And with the count with conditional expression is like very powerful, and we are definitely using it in most of the production environment to deploy the resources dynamically based on the condition we do have. So let me show you one of the good example we do have in our project is let me show you that in the prod, I do have only two databases, right? I wanted to create only two databases, but in test, I wanted to create four databases, right? So for the prod and the test, there are some differences between the databases. So now let's create the databases first, and then I'll show you how we are going to define, or based on the war.environment variable and using the count row, how we can configure the Terraform code in a way that as soon as we are going to pass the war.environment is equal to test, then these two additional databases will be deployed. And if we are passing the Terraform dot like environment is prod, then only two databases will be deployed. So let's have a look. I'm going to create one file just to keep it simple, database.tf, and I can show you the code in a more better way, and it's easy to manage if I do have a separate file for the resource. Now the first thing I have to create is the SQL Server. I'm going to copy the code from the Terraform documentation, and this is my SQL Server, right? The naming convention of the SQL Server, I can take it from here like this, and I'm going to put the naming convention, and as you know, we are already using the variable as an interpolation for the naming convention of the resources. So I'm going to put this like this, and then we do have the resource group called RG, and then another one, rg.location. Version I wanted to keep same. Administration login and the password, not good to have in a plain text, but for now I'm just keeping it in a simple way, and I'll show you how we can make sure like it will be more secured way. So for now I'm going to remove this. I don't want any AD authentication. I just wanted to keep it simple. And then I do have the local.tags. I'm gonna do the Terraform formatting. Okay, that looks good for the SQL Server. So I'm fine with the SQL Server. I need the SQL Server in both the environments, so that is fine. Now I wanted to create the databases. So we have separate resource block for the databases. And if you go to the documentation, there is something important which we should follow. And I explicitly open this documentation because this kind of information you can see everywhere in the Terraform documentation, and just don't skip it and go through it. To mitigate the possibility of the accidental data loss, it is highly recommended that you use the prevent destroy lifecycle argument in your configuration file for this resource, because in the database you have the data, right? And that data will be very critical data for your environment. All the information, everything is in the data, right? So it is always better to have the prevent destroy. Otherwise, let's assume you are making some changes and accidentally there might be possibility to delete the database, which is accidentally deleted, so you can prevent it. It will complain when you are going to run the Terraform destroy or any other command which is going to destroy your database. So just make sure you use the prevent destroy for the data related services, specifically like storage account, database, and others. Now let's take the example of the SQL database. I'm going to use it. And how many databases? Four databases I wanted to create for the test. So first I will just copy it. The first database is the demo DB, or I can take the example of application DB. I'll just copy it in the naming convention, and this is the application DB, right? And again, I'm going to use this thing here. So I'll just quickly replace it. Okay, that goes good. Now the second thing is the SQL Server itself. So I'm gonna refer the SQL Server in the SQL Server ID. So this is the SQL Server dot ID. The rest of the information I wanted to keep simple, and the SKU I wanted for the basic. I don't want enclave type. These are all the properties of the SQL database. You can choose if you have any specific requirement. And then I have this one, and then there is a prevent the possibility of accidental data loss. If you want, you can keep it. If you want, you can remove it, but it's better to keep it with the production environment. For the test and dev, you may remove it if you are just like keep deleting your environment. Okay, that is one of the database. Second database is Angogger database. I'm just going to copy, and I know the name is just Angog here and Angog here. Rest of the information should be same. Yes. Now third one is the fin demo. So I'm going to use the fin demo, the third database. And here also the naming convention is fin demo. Okay, that looks good. And the last one is the demo itself. So I'm going to use the demo here and here. Okay, looks good to me. one SQL Server with 4 databases because we do have the test environment. Let's run the Terraform plan command to see if it is creating one SQL Server with the 4 databases. But in the pod, it should be just 2 databases. So first, let's have a look for the 4 databases in the test environment, and then I'll show you how the conditional expression we can use with the count group to make sure that these 2 databases should be created only with the environment type test, not the pod. Okay, I can see the 5 resources here, SQL Server, and then the 4 databases. Okay, that looks good. Now let's have the conditions expression. Fin demo is something we don't have in the pod, right? We have only application and debugger. Fin demo and the demos doesn't part of the pod environment. So what I'm going to do is I'm going to use the count if var.environment. So this database should only be created with the test, not with the dev, sandbox, or prod or anything else. Only the test. So my condition would be with the count group var.environment is equal to if like count. I'm basically deciding the count of this resource. I can deploy 1, 2, 3, 4, 5, right? We already saw that how the count group work. But in my condition, in this condition expression or in this particular resource, I wanted to create either 1 or 0. Like I wanted to create one database if it is test, if not, then should not be created, and should not be created, that means the count should be 0. So what I'm going to do is if var.environment is equal to test, then create 1, else create 0 for any other type of environment. I'll do the same condition here. Save it, run the Terraform format command and clean it. So again, let me explain it. The count of these 2 databases will be depend on the value of the var.environment. If it is test, then it will create one resource of the fin demo and the demo DB. If it is not test, then it will not create at all. Okay, so let me run the Terraform plan again. Technically, it should again create the same number of resources, 5 resources, 1 SQL Server and 4 databases. Why? Because my environment type is test right now. Okay, so let's see. Yeah, that is still same. Now what I'm going to do is I'm going to replace the environment with the prod, and we are going to see if it is still creating all 4 databases or not. But there will be a lot of other changes as well because we already apply the resource group and everything, and the naming convention for this environment is going to be changed for the prod, and everything other changes will be there, but we will just focus on this databases changes. So I'm going to run the Terraform plan, and I just wanted to check if it is creating these databases demo DB and fin demo or not. So let's run the Terraform plan. There will be a lot of changes. There might be a lot of destroy, and the creation and the number of addition might be different, but we will focus on, yeah, so you see 5 destroy and 8 to edit. So I'm only going to focus on this SQL database related resources. So I can do this one, and then I'm gonna find, maybe do the control F, SQL Server. Okay, so the SQL Server will be added. That is fine because I wanted to create the SQL Server. So SQL Server doesn't have any condition, so it will be created either the environment is test or the prod. And then another one, I do have the database. So the first one is nlog database is there and application DB is there. But what about the fin demo? So I can see we do have this references here, and I don't have any result for this database, right? That means the condition is working fine. It is not going to be created. If you wanted to check in other way, just a clean check, then there is another option with the Terraform plan and apply command, which you could use. That is Terraform plan hyphen target, which will target for a specific resource. So I wanted to check if nlog database is going to create or not. So I can run the Terraform plan for just for this block using the target command. Okay, so this is how we are going to use it. Terraform plan hyphen target is equal to SQL database dot nlog underscore db, and I'm going to run the Terraform plan. There will be some warning that this plan or this apply is going to be executed just for one resource. So that is also we can do. If we wanted to check for one resource, one specific block, what would be the impact of the changes, that is also we can do. So I can see here there will be a SQL server, okay, and then there will be a database. So I can see, because I can see the SQL server because it does have the reference of the SQL server ID as well. So even though I'm targeting just the database, I can see both these resources are there. And it does have the references for the SQL resource group. The SQL server does have the references for the resource group, so it is showing me the changes for the resource group as well. So all the interconnected or integrated resources can be shown with the target. But at the end, I wanted to see the database, what would be the impact. So there is impact, the database is going to be created. Now I wanted to check for the fin demo because my environment is prod and technically it should not be created. So let's run the Terraform plan for the fin demo underscore DB and see what would be the impact of the war.environment conditional expression here. Okay, there is no change. Like the database is not going to be created. The resource group and the SQL server is there. It is going to be created, but database is not going to be created. And that is what we want. So with the help of this count group, we can configure this kind of a situation. And it was a requirement for our environment that test should create these two databases, but not the prod. And we are using the same code. So what we could do is we can just put the condition. If the environment is test, then only these databases should be created. If the environment is prod, then that should not be created. So this is how we can use the conditional expression with the count group. And if you have any question, you can put it into the comment and I'll try to answer it as soon as possible. Hope you enjoyed this session and I'll see you in the next one. Thanks for watching. So in the last section, we discussed about the count group. We saw the example that we can create multiple resource group using the same resource block by using the count meta argument or the Terraform expression. We can provide the count as a number, like how many times we want to iterate that particular resource block. And we use the count dot index to differentiate the naming convention every time when it iterate, right? And that is the example, like how we converted the three resource block in a single one. If you have noticed that in this example, we have only changed the naming convention of the resource group. And that's why we were able to use the count.index and we were successfully able to create the resource group using the count and the single resource block itself. What if the location of those resource group is not the same? There are something like for the resource group 1 is West Europe, for the resource group 2 it's East US, for the resource group 3 is West US. How we are going to use the count now? How we can make sure that we can still use the same resource block to deploy the multiple resource group having two different properties, right? Last time we were able to use it because we can just differentiate on the naming convention itself. We use the count.index and every time it iterate, the naming convention was getting changed and the resource group was successfully created. But if you have noticed that location was still same for all three resource group. But in this kind of a scenario where we have more than one property which is going to be changed, which is different from each resource, then how we can make sure that we can still use the grouping. So for this kind of a scenario, for this kind of a complex scenario, I would say we can use the for each group. And that is again a very important in the Terraform because we can iterate it or every resource block or the data source with the help of the for each for the multiple properties where the multiple properties are getting changes. Like in this scenario, the resource group name is getting changes as well as the location is getting changes. So we can use the for each group in this scenario. Let's have a look how we can use it and how the for each group works in that kind of a scenario where we have the multiple different properties. The very first thing which we have to see is for each is always work with map, or we can also use the list to iterate multiple times. So if you see the example now, we do have the variable called RGs, and we can see we do have the key is a resource group 1 and we do have a different location for the each resource group. So this is how we can define the multiple properties or multiple key value pairs where we can have the key as a unique value. We already discussed about it in our variable section about the maps. So in this kind of a scenario, like where I do have more than one property, for now we have two properties like name and the location. So we can use the map where we can assign the key as a name of the resource group because it will always be unique. We can't create the same name for multiple resource group. We can't have the same name for multiple resource group. And so my resource group name is unique here. That's why I'm choosing resource group name as a key. I could also choose the location as a key, but then what would happen? Let's assume I have to create resource group 1 and 2 in the same location, but resource group 3 in a different location. Then I'll not be able to do it because I can't have the same key in my map variable. That's why I'm using the resource group 1 as a key and location as a variable. So value, not variable. So location is a value. Value can be same, but key should be unique. This is what we discussed in the map variable. So here in the for each condition, we can have the map as a variable where we can assign the unique value as a key, and we can have the another property as a value, and we can iterate on this variable. So let's have a look how we can make sure that we can iterate in this format with the help of the for each group instead of the count group. So let's assume we do have this resource group block again. And what we could do now, we will have to use for each is equal to var.rgs. So this is how we are defining the meta argument of for each or Terraform expression for each for the looping on a multiple values. That is the first thing we have to write down in our resource block. Okay. Now, what I have to change, I have to change the name. I want to pick the name from the key. Then what would I have to do is I'll just simply remove the name and I can use each dot key. So we are using for each. For each will iterate on var.rgs. Like for every key value of rgs, it will iterate. It will pick every key and value pair at once. So it will pick resource group 1 first, then we'll iterate again, pick the resource group 2, then iterate again and pick the resource group 3. And every time I want, the name should be each dot key because I know my resource group name is a key of the map variable. So every time it will pick resource group 1 is a key from the key, and then location is each dot value. Simple English. So each dot value will be iterate values. And now let's run the Terraform plan and see what would happen. So if you can see now the iteration again, the first iteration identifier and first iteration RG in West Europe, second iteration RG in East US, and third iteration identifier in the RG, if you see, it's in the West US. So in that case, in the for each group, we can use the each dot key and the each dot value. So if we have more than one parameter which is getting changed and we wanted to iterate on that resource block level, then we can use the for each group. And we can iterate on the each dot key and the each dot value. We we are going to talk about if we have more than two, because now we are talking about just two. And let's assume if I have like more than two properties, so I'll show you how we are going to use it. That is also we can achieve with the help of the for each group itself. But how, that is something I'll let you know. But here, if you see, if I'll have to change just two parameters, then I can use the for each group. I'll have to define those value in a map variable, and then I can use the for each group, and then I can define them as a each dot key and as a each dot value. So it will be iterate on each key at a time, and we'll pick the key as a name and location as a value. So that is how we can use the for each group in a simple way, and I'll show you in an advanced way in a while. Now let's take another example. Now we do have an example where I have to create three NSG, three network security group. And if you can see in the example, we have three properties now, three arguments, and it can be more than three arguments. So in the NSG1, I can see the name is NSG1, location is West Europe, and resource group name, because we have to provide the resource group in the NSG is a argument, is a required argument, and the resource group name would be the RG1. And if you see, all three NSG have a different name, different location, and different RG. How I'm gonna do it now? Because I can assign the each dot value and each dot key. What if I have more than one properties? So let's have a look. If I have this kind of a scenario, what I'll have to do is, again, I have to define a map variable, but this time, what I'll do is, I'll have the NSG name as a key, and value will be another map. So I can assign another map in the value of the map. So that is also we can do in the Terraform. So when you're assigning the value in a Terraform for the each key and value of your map variable, you can assign the key and value can be another map. So in this kind of a scenario where we do have multiple value related to one argument or one object, then we can assign this kind of a map variable. So for NSG1, it would be NSG1 is equal to, again curly braces, and another key value pair. Location, West Europe, RG, RG1. So now I have defined that with each key value pair, there will be a location which will be West Europe, RG will be the RG1. Okay, so I have defined the NSG1, NSG2, NSG3 with their appropriate value. If we have more than two values or more than location and RG, then I can define the location, RG, maybe the size, ports or something like that. That is also I can do in addition of this. So this is how we can define the variable or map variable now. And based on this map variable, we can assign the iteration on our resource block level. So let's have a look. Similarly, for each is equal to what dot NSGs, like what we have defined with the resource block in our previous example. We can do the same here. Name is dot key, because name is key again, so I don't have to make any changes into the key. The next two parameters or next two arguments I'll have to change, but key is still key and the name of the NSG itself. So I can keep the name is equal to is dot key. Location is dot value, but not just a value. I need location from the location of my value. It's a little bit confusing, but with the map variable, you can actually pick the value by providing the key. And in the second example, if you see, in the second one, like in a value of your first map variable, like NSG1 is equal to, you can see that there is another map. And in this map, in this nested map, you can see key is location and value is West Europe. Key is RG, value is RG1. So now I can assign or I can define or I can call that location by providing each dot value, then square braces, and then the name of your key. And in my case, the name is location. And for this purpose, I'll need to assign the location as a key for each NSG property. Then only it will, the for each will iterate, will try to find the location as a key. If it will find the location, then only it will call the value. So from the nested map, it will try to find location as a key and will get the value of that particular location. So to define that value, what we will have to do is each dot value, square braces, and in the inverted comma, you will have to define the value of your key. So we can have the location as a key. Similarly, for the resource group, you can do the each dot value and then RG of your nested map variable, key of your nested map variable. So that is how I can define the resource group name. And if I have more, then I can do the same similar thing. So we have to define the map variable, and inside the map, we will have to do a nested mapping. So for the value of your NSG will be another map variable where we can define the properties like location, RG, size, whatever the properties you want. And based on that properties, you can call them in the for each loop. Now let's run the Terraform plan and see if it works. So see the iteration. In the first one, the location is West Europe, name is NSG1, RG is RG1. In the second one, East US, NSG2, RG2. In the third one, West US, NSG3 and RG3. So this is how we are defining a multiple properties using the for each loop, and we can iterate based on it. So it's all about the map variable, how you define your map variable, and based on that, you can call the for each loop on your resource block, and you can use and you can iterate your resource block using the multiple properties or where you wanted to use the multiple properties. So with this example, you can define like a multiple properties, more than 5, 6, 7, whatever the properties you have. Like in virtual machine, we might have size, we might have the nick card name, we might have the availability zone, availability set, and there are a lot of properties we do have with some resource block. So we can define in this way, and we can iterate based on the multiple properties, and we can use the for each group, use the single resource group block, and iterate based on it. So that is how it works. Now let's have a look to the another example, because for each group is very important, and that's why I'm explaining a multiple options, because we can use the for each group with in a multiple way. We already saw we use with just key value pair of a map. In the second example, we saw if I have multiple properties which is going to be changed, then I can use this kind of a scenario. And let's have a look to the another one. Now let's have a discussion about the another scenario where we can use the for each group. Let's assume I wanted to create three resource group called rgprod, rgtest, and rgdev. And they are in a same location, West Europe, West Europe, and West Europe again. So it's only one property or only one argument which we will have to iterate on. So what about using the count instead of the for each and keep the thing simple? Will it work? I think it will not, because with the count group, I can iterate on the numbers. And if my naming convention includes like resource group 1, resource group 2, resource group 3, that time I can use the count group and I can iterate on the number basis and change the resource group name, the number of the resource group name like 1, 2, and 3, which we did in our example. But here in my scenario, now I have a different case. I have rgprod, rgtest, and rgdev is a naming convention of my resource group. So definitely count is not going to work here, because it is not a number, or it is not iterating over the number, or the number is not the thing which is getting changed in the naming convention of the resource group, but the string itself. What I can do is the same thing. We can use the for each group, but in the for each group we saw we are using the key value pair, right? We are using map variable, and we are iterating on both key and values. So what we should do now? We can do the same thing here as well. We can have the key value pair, and instead of using the each dot key, each dot value both, I can use the each dot key. That will work. That will for sure work. But then what I'm going to put into my values? I can maybe have the location, but do I need it? I don't need it technically, because the location is same, only the name is going to change. So what I can do is, instead of using the map variable, I can also use the list as a iteration. So yes, we can use the list to iterate the for each group. For map it is working. Definitely we can use the map here as well, but when we don't need it, we don't need to make it complex. Unnecessarily don't make it complex, because we can iterate the for each on the list as well. So I'm putting this example in my video because most of the people doesn't know we can use the list to iterate over with the for each, and that's why I'm showing the example here. Like we can use the list to iterate over with the help of the for each, but there is some scenario which I'm gonna explain. But first let's have a look what we will have to do in this example. So the first thing which I'll have to do is I'll have to create the list, and type would be list any, or I can use the list string because the list is it's a list of string, and the value would be rgprod, rgtest, and rgdev. Similarly, I'll have the resource block. I can do the for each var dot rgs. Then name would be, in the list we have only values, we don't have the keys, right? So in that scenario, what I'll have to do is I'll have to use the each dot value, and location is equal to West Europe. Will it work? Technically it should work, right? Because list we are taking the each dot value, we have defined the for each, everything looks good. And here most of the people are getting confused and think like list doesn't work with the for each. So let's have a look. I'll do the Terraform plan and let's see if it is working or not. Oh, so it's not working. Why? Let's see what is in the error. Argument must be a map or set of strings. So it can be a map like a map variable, or it should be a set of strings. So that means, does list work with the for each or not? It works. It works, but you have to make sure that your list has the unique values, because in the list you can define rgpod twice or more than one time. But when you are iterating on it, then Terraform will not be able to iterate on a same string or same key again. So even though I have the multiple values with the same name, but my Terraform will not iterate on it. My for each loop will not iterate on it. And why so? Because for each loop is using your iteration as the identifier. When you are referencing, and if you go to the state file, and you will be able to see in the count, the iteration, the reference was 0, 1, 2. If you remember, we have defined, like when we are calling values or calling a resource group which we are using with the count in a different, like in a virtual machine or any other object, what we will have to do is we have to use the square braces and put the 0, 1, 2 based on the iteration. But in the for each group, the value itself used as a in map, the key will be part of that iteration or that reference. But in the list, we don't have the key. So now the value will be the identifier of your Terraform reference, and I'll show you the example. But that is the reason the value or the iteration or the variable where you are iterating should have the unique values, right? And how the unique values should be in a list. So to make sure that the list which you are providing have all the unique value, we do have a function called set. From that function, we can pass the value, and then we can use the set as a function in our for each loop to make sure or to get Terraform know that my variable, my list variable has all the unique values. So let's see how we can do that. And if you can see into the error as well, you have provided the value type list of dynamic. So we have to provide the value type of list is a set, and set makes sure that your list is unique. Like every value of your list is unique. Like RG prod, RG test, RG dev. I do know that they are different. They are unique. They are not matching with one another. Right? I can see it. I can tell about it. But I'll have to get Terraform know that they are unique. And to do that, what I'll have to do is I'll have to change the for each loop, and I'll have to use the toSet variable. What it will do is it will set the war.rg's list into the set format, and it will make sure that this value is all the value of this list is unique. If it is not unique, that then this function itself will fail and the loop will not iterate because it will error out on the function itself. So this is how we can use the list to iterate over with the help of the for each. Let's see now if it is working or not. So yes, it is working now. I can see the name rgdev, rgprod and rgtest. So this is how the Terraform works with your list, and you have to make sure that your list is unique or your value of your list is unique. And if you can see in the Terraform plan, the Azure RM resource group.rgs, and in the square braces rg-dev, rg-prod and rg-test is your reference. So whenever you are referring this resource group to anything else or to any other resource block, then you have to make sure that you are writing in this format. And that was the reason, if you see in the square braces of your Azure RM resource group.rg, is that this value should be unique. Otherwise, it will match with the another block. So each block should be unique. That is what we have discussed, like the name and the resource block should be unique. So in our case, it's rg-dev, rg-prod and test. So we'll have to make sure that our list which we are providing in our for each group should be unique, and that is something we can do with the help of the toSet function. So this is how we are using the list as a for each input, and we can iterate on the list itself. So that's all about the for each group. Now let's have a look in a practical way how we can use the for each group in a multiple scenario in a production way. I'm going to show you with some real-time examples. So let's have a look. So in this section, we talked about the for each group. We already discussed about the count group and the conditional expression. In this one, I'm going to show you how can in real time we can use the for each group. So we discussed about the database creation last time and using the conditional expression with the count group for the databases, which we just need for the test environment and not for the production. Now let's assume there are some changes. So there is some requirement that application DB should be with the basic SKU in the test environment, but with the S0, P0, something like that, like some different production grade SKU for the production environment. What can we do here? So either we can use the conditional expression again here, like putting the condition environment is test, then use the basic, and the if environment is prod, then use something rather than the like P0 or something like that. But going forward, we might have to change it from P0 to P1, P2 or something like that. So conditional expression can be used, but it will make our code more complex, more complicated, and also it will not be very feasible or flexible, I would say. So what we can do here is we can use the for each loop, and we can just move all this databases configuration into the map variable. And based on the map variable, the databases will be created. So for that purpose, we can use the for each loop and the map variable combination to deploy all these databases. And to do that, what we could do is we know that we are creating databases and there is some naming convention for that databases. And then on top of that, we do have some configuration like a license type and the maximum size DB and the SKU. The license will always be included, so I can keep this particular argument as a fixed value. So I'm not going to change it. The correlation will be same for all of the databases, so I can keep it same. But size, SKU, and the name of database is going to be changed. So to achieve this requirement with the variable, what I can do is, first of all, I'm going to create a new variable, and that variable will be the databases, and I can put the description and the type and all. For the type, I'm going to put the map and then the string. For now, I'm not going to put the description, but you can choose whatever the description you want. And I want the map of a string. Now, what values I can use is a map variable. So I need a name, I need a SKU, and I need a maximum size of GB. Okay, so let me define the variable first. And based on that variable, we are going to update our configuration. So I'm going to use the databases. The first one will be so here the name I can use as a key because I need like all the names should be the unique. And as I have explained before in the map, the key will be the unique value. Value can be same in two map, like I can have another one called name2 and the value could be the value itself. But I couldn't have the name again. It is not a right way of like writing the map variable. Two keys can't be same. Okay, it should be unique. So what I'm gonna do is I'm gonna use name as a key. So I do have one database called app database, right? So I'm gonna use app, and then I do have two values over there. So it will be again a map, and then in this map I'm gonna use maximum size of GB, that is for 2 GB for now, and then the another one is the SKU name, and I'm gonna use the SKU name that is basic. That is for the app database. I do have another database that is called nlog database. I'm gonna do this. I'll use the name as a nlog. GB is same and SKU will be the same. For the app database, I need S0 because it's my application database, so it should have a good performance. For test environment also, I need at least the standard 0 SKU, and the GB should be 10 GB. And for the nlog database, that is a logging database, so I can have the basic itself and I can define this variable. Let me just quickly run the Terraform format command so I can format it. And for the test environment, I do have a couple of more databases. So the another one is the fin demo. I'm going to use the same reference as nlog. And again, the another one is the fin demo. And the last one is the demo. So I have four databases. For the fin is basic is 0 again and same size, but for the demo, it should be 2 basic again. I'm going to do the Terraform format. I do have four databases now, app, nlog, fin, demo. And now what I can do is I don't have to write the databases block again and again. So the benefit of the map variable would be with the for each combination that we don't have to define the block for each and every databases. So let's assume right now we have four databases, but going forward we might have to create couple of more databases. So then we have to come to the database.tf and write the block again. Instead of handling in that way, what else we could do is we can handle this thing from the variable level itself. So whatever you can handle from the variable will make your code more flexible, right? So even though you don't have to use this conditions and everything over here, you can have just only one block, and I'll show you how. I'm going to delete all three block. I will have only one block for the database called the databases, and now I'm going to use the for each word dot databases, right? And the key is name. So I'm going to replace the name here, same with the interpolation, and I'll use the each dot key. So whatever the name or whatever the key we will have in this database map variable will be replaced here as a name. Okay, environment, location, and everything looks good. Now the size, the another thing which we have to do is, so we have the value here. So this is key and this is value for each condition. And inside the value, we have this maximum size of GB. So what I can use here in the maximum size from each dot value dot maximum size of GB. Similarly, I am going to do here each dot value dot SKU name. So these conditions I can configure in this way, and whatever the variable I have provided, based on that, this particular resource block is going to be looped. Okay, so this is how we are using the for each loop, and we don't need like four different blocks or resource block for the databases to create the database. What I can do is I can manage it from the terraform.tf vars itself. So for the production, what I'm going to do is I'm going to remove this one, and it will create just two databases. So I don't need the conditional expression. I don't need a separate resource block for that. Let's have a look. I have executed. I put all the information here in the terraform.tf vars. I have the for each conditions here from where I am getting the each dot key as a name. So whatever I do have here as a key will be replaced in the naming convention of the database, and that is what I want. And the naming convention of the database should be the unique as well, right? And this is the only unique identifier we do have, because environment is same, location short is same, SQL DB as a prefix is same. Only the name of the database was unique. So we are replacing it with the unique naming convention here. And for the rest of the configuration, we are using each.value dot maximum size underscore GB and dot SKU name. Now let's run the command and see how it is working. Okay, so it seems like we did some mistake on the variable definition. So you can see on the nlog element, the string is required. So what I'm gonna do here is I'm just gonna change the type and the Terraform plan again. Okay, it looks good now. So the error which we got because of we configured the map as a string, a map of string. But if you see in the value of our map, we do have the numbers. So technically all the values should be in the string if we are defining a map of string. But if you have a map with multiple type, like I do have number and string both. So what I can do is I can go to the variables and define map of any, which will include the numbers, string, and whatever the other types you have. So whenever you are defining the map, you have to be make sure that you're going to use all the values of a string, or if you are going to use the mix. If you are going to use the mix, then use the any. So though the Terraform itself is like mature enough or intelligent enough, if you are not defining the type, it will automatically take whatever the type is there. But if you wanted to make sure like every time the type should be what I'm providing, then you have to use the type. But if you are not using the type, still the Terraform will use its own intelligence and will see what is the variable definition we have configured, and based on that, automatically it will configure whatever the required type is. But if you are defining, then you have to make sure that you are defining the correct one. The last time we got the error because we have defined the map variable as a map of string, but we do have the numbers as well in the map. And that's why we got the issue. Anyways, for now, it's working fine. And I can see 5 resources to be added, one SQL database. And let's have a look to the database. SQL server is there. Now let's have a look to one of the database. nlog. Okay, so the database nlog is there. Let's see the name of the nlog database. Okay, I do have the current naming convention. I do have the key of nlog in the name of the database itself. And the SKU is basic. That is what I want. And the maximum size of GB is 2 for the nlog. So that is correct. Just to make sure it took the correct one, I'm going to use the fin demo as an example, and I can see the SKU name is S0, which I used, and the size of the GB is 10 GB. So that is another way of configuring the databases or deploying the resources using the for each group. We have to use the for each group, and like whenever we need this kind of a repetition, and it's always have good to have the flexibility in your code. So going forward, if I have to like make any changes, introducing a new databases or something like that, or deleting these databases, I don't have to go to the code. My code is flexible enough. I can manage it through from the variable itself, from the terraform.tf vars. Right? So we don't need the like a knowledge of the Terraform. Like if someone is in the team who doesn't have the skill set of the Terraform, or if you want to make sure that that code is flexible enough to understand for everyone and flexible enough to be modifiable from everyone. Anyone can do the modification. So you can manage it in a way that you define most of the values from the variable itself. And for the pod, I'm gonna do this kind of a stuff. Like I'm just gonna remove this and I'll run the Terraform plan command, and then only the app and the nlog database will be created. So with the help of the for each group, we can configure the dynamical way of deploying the resources and do the grouping in a dynamic way. So that's all about the for each group. Let's have a look to the plan. And yes, it worked as expected. And that's all about the for each group. I already explained it into the slides, but I wanted to show you in this way, in a project way, how we are going to handle it. So hope you understand it. And if you have any question, you can always put it into the comment. And I'll see you in the next one. Thanks for watching. Now let's talk about the third type of the group which we have in the Terraform. When I started the grouping in Terraform, you might have think about like this is very difficult. This is very difficult to understand. And when we were discussing about the count, you thought like, so it's very difficult. But when I started discussing about the for each group, you thought like count was very easy compared to the for each. Now when I will start with the for, I'm sure you definitely will think for each much easier than the for group. And that was my personal experience. Like in initial years, I was not even able to decode like how the for each or for loop is working. For each was simple, count was simple. We know like count just iterate on the number. For each was also kind of a simple, because we can see there is a key value pair and we can use the iteration with the for each to iterate over the key and the value. But for was always difficult to understand. It was very difficult to decode it, and when we are using, and I personally advise to not use for when it is not required. It's making your code very complex and very difficult to understand for the person who is going to read your code or understand after you. So anyways, it's a very important one, because the things which we can do with the for loop you can't do with the any other grouping, and it is very helpful in resolving a complex scenarios, complex transformation of your variable in the Terraform. So for loop is basically not iterating, but it is helping in the transformation of your variable. So we are not using for with the resource block itself. Instead of that, we are mostly using, we can use, but we are mostly using it with the variable itself to transform the value of your variable in a different way. So I'll show you some example, and we'll try to make sure that it will be easy to understand. I tried my best. I have spent a lot of time on this, on the slides of the for loop itself, to make sure that it is simpler and you guys are understanding it and decoding it in a simpler way. So let's have a look how we can use the for loop. Let's assume I do have a variable called NSGs, and it's a map variable, and I do have the value NSG1, NSG2, and NSG3 as a key, and then I do have a property as a value, like a nested map, which we already discussed in the for each. And there is a requirement that the key should be transformed. The key, the NSG1, 2, and 3 should be transformed in a form that NSG1 should be merged or have environment is a suffix in the key. So let's assume my requirement is the key should be nsg1 hyphen prod, and it's not prod but whatever the value I do have in the environment. Similarly, nsg2 should be nsg2 hyphen the environment, that is test, and nsg3 should be nsg3 hyphen dev. So whatever the variable or value I do have in the environment, I want to merge it with the key itself. So for now my key is nsg1, 2, and 3. but I want to transform my key with merging it with the environment, and I don't know what would be the value in the environment, right? So I wanted to transform. Let's assume I do have a like multiple value in my multiple key value pair in my map variable, and I wanted to transform in this way. How I can do that? With the for loop, I can transform this value and see how we can do that. First thing, I'm using the output block to show you the example. So with the help of the output block, we can print the output by running the Terraform plan and apply command, and we can see if we are able to do what we are trying to do in a display picker way. So you can display it and you can see it if the required transformation is happening or not. So that's why I'm using the output block. The output would be the energy value. The first thing we have to define is the curly braces. So it can be curly braces or it can be a square braces. So when we are using the for loop, the first thing we have to define is what would be your output, or what type of output you want. So you can transform map variable into the list with the help of the for loop, and you can also do list to map variable with the help of the for loop. And based on this assignment, like if you are using the curly braces, that means the output of this for loop will be a map variable, will be a key value pair. That was very difficult thing to understand initially, like how this thing is defining it. So that is the main thing. If your for loop is inside the curly braces, that means the output of this for loop would be key value pair, a map variable. Okay, and if it is list, then it will be a square braces, and your for loop will be in your square braces. Let's have a look. We will gonna look into the list output as well, but for now I want a key value pair. I just wanted to transform my key, and value should be same as it is what I do have right now, like location, RG, and environment, but my key should be transformed and my key should have the environment name included. So let's have a look. The first thing which we will have to do is using the output format, like what would be output of your for loop. So in my case, I want a key value pair, so I'll use the curly braces. That is the first thing I'll do. Second thing, for kv in var.energy. So here we are using the for loop. K represent the key or the key of your map variable. So it will iterate on the key value, same as for each loop was iterating in our resource block level, but here we are doing the transformation. So for k comma v in var.energy. So in var.energy, k will represent the keys, v will represent the value, and in our case the value is a map, right? Another map. So for k comma v in var.energy, then I'll have the column. With column, I am representing that for k in kv in var.energy, and now it will iterate. Okay, with column it will iterate, and the next thing which I'm gonna represent will be the outputs. So what I want is I want k hyphen v dot environment. So I wanted to merge k is key because k is representing the key. So with each iteration, the k will be represented like in the first iteration it will be energy 1, in the second energy 2, in the third it will be energy 3, hyphen, and then with the help of the interpolation what I am using is v dot environment. So we know value is the whole map variable, and from the map it's again a map, and the key is location, RG, and environment, and value is assigned to that. And what I wanted to pick from the value is v dot environment. So with the help of this value, I can have k. So with each iteration, it will pick the k because k representing the key, and it will pick the v dot environment, like which with each iteration, it will pick the environment value from the value of your map. So it will be v dot environment, and then there is a special sign that is equal to and the greater than sign because we are transforming it. So far we have defined the key, the output key, and the output key would be k hyphen v dot environment, And now we have to define the value. What would be the value? We wanted to keep the value same. So what I'll do is I'll just put the v. So this is our transformed key and this is our transformed value. In case of the value, we didn't do anything, so we just represented the v itself. So I know it's a little bit complicated, difficult to understand, but let me explain it again. In the first one, we are defining the curly braces because I want output in a key value format in a map variable. That is what I have defined is a map output in the curly braces. Then for loop, so we start with the for k comma v, k represented the key, v represented the v. So v represented the value, and if you want to use, you can use the ab, whatever you want. You can use it just a constant value you wanted to use, because after this colon sign, this value will represent key and value. So in most cases, even in the Terraform documentation, if you see, it will be represented as a key, k comma v. But if you want, you can type the whole k, e, y, key and v, a, l, u, e as a value. But I personally prefer to keep it like simple. K will be key, v is value. You can also use a to represent the key and b represented the value. But that doesn't make sense. So that's why I took the same example as the Terraform documentation. K will be key and v will be your value. In var.nsg, in var.nsg map variable. Okay, then I wanted to transform the key, so I did some interpolation thing and merging with the key. So after colon, I am representing the key because the output would be the key value pair. So after the colon, the first thing I have to define is the key. So in my case, I am defining the key as a key hyphen the environment name. If I wanted to use the location, I can use the v dot location, I can use the v dot rg, whatever I want to merge it. So whatever I wanted to do, I can do here. If I wanted to define a whole naming convention, then I can use the key hyphen v dot location, v dot rg, v dot environment whole as a key. And after that, I'm using the equal to and then the greater than sign, basically a arrow sign, and then I have to define the value. So in my case, I wanted to keep the value as it is, same what I do have right now. So that's why I'm just representing the v. So that means in the output also the v value will be the same. If let's assume I have a scenario where I don't want the whole output again, because environment I already used in the key, now I don't want the environment and I don't want the rg in v value. I just want the location as a value. What I can do is I can define the v dot location. So the value will be, or the output will be, key nsg1 hyphen pod, and the variable value will be whatever I want. So I can even use the simple one, location itself. Or if I wanted to generate some list, that is also I can do. So that is how I can transform my variable. And let's have a look. If I run the Terraform plan, then what would happen? Now let's have a look. So if you see the output, now the output will be nsg hyphen pod and the value of my variable will be same. We didn't make any changes in the value, in the transformation of the value. So that's why we have the same value. But in the key, we made some changes. Earlier it was NHG1, now it is NHG1 hyphen prod, NHG1 hyphen test, NHG3 hyphen dev. So that is how we can use the for loop to transform the value. And I'll show you in the example, there are some good scenarios. In the practical, I'll show you where we can use the for loop. But again, like if you are comfortable with the for loop, if you can put like a good comment in your code to explain why you are using the for loop, then only use the for loop. But if it is not necessary, then avoid to use the for loop because it is making your code very complex. But in some scenario, you will not be able to like transform the value, you will not be able to do what you want without the for loop. And I do have some scenarios in the production which I'm going to show you in the practical way, like where we are using the for loop and why we are using the for loop there. But in most of the cases, the for loop is very important. It is helping us a lot in making our code simple and iterating on different variables, and we can transform the variables and use the values over there. Okay, so that was the example about the if the output of the for loop we want in a key value pair itself, wanted to transform it into the key value pair and just transform the key itself. Now let's have a look in a different one. I wanted to generate the list. I just wanted to get like some specific value from the map, pick the specific value from the map. So let's have a look. So now I want the for loop output should be list. So that's why I'm using the SQL braces here. So whatever I'm gonna define as a variable will be output type of my for loop. Here I wanted the output in a list. So that's why I'm using the SQL braces. Earlier it was curly braces. Similar to the previous one, for k comma v in var.nsg. And now we don't have to define the value because my output will be just a list itself, and in the list I know only values are there, so I have to define only the values. And in my case I just wanted to transform this particular map variable and pick all the environments in a list format. So what I'll do is I'll just simply define the v dot environment. What this for loop will do, it will just pick the environment from each key value pair of my map and will output is a list of those environment. So let's have a look. Okay, so you can see the output is environments is equal to prod test and dev. So all the environment it picked from my key value pair, my map variable, and just output in the format of the prod test and dev. So if I want output in a list format, I have to use the square braces, and then I have to present only the value, and I don't have to use the key and then that arrow sign to define the value. Okay, now we just have to define only one value because in the list we have only one value. We don't have the key value pair. So that's why we are just defining v dot environment, and we can use anything else as well. Okay, let's have a look to the another scenario where I want only the prod environment should be picked up. I want a condition where only the prod environment should be picked up. So that means now we will have to use the if condition because we do have the if condition now, right? Where the v dot environment is equal to prod should be my output. That is what I want from all the key value pair which I do have in my map variable. So if I have like a 50 key value pair in my map variable and I just wanted to pick the prod environment where we do have the prod as an environment. So what I have to do is I have to use the if condition in my list, and the if condition would be the if v dot environment is equal to prod. For loop with if condition. That means now it will check for k in v in RGs and output v dot environment only if v dot environment is equal to prod. Or I can also do v dot rg is equal to rg1. So output all the environments which are in a rg1. So that is also I can do. Or I can do v dot location is equal to West Europe. And then I can use another condition and make sure that v dot environment is equal to prod. So that is also we can do. We can do multiple conditions, and then it will check for both. If West Europe is location, prod is the prod, then the output should be the v dot environment. Or I can do the k as in output instead of v dot environment. I can use the k if v dot environment is equal to prod. That means list out the NSG name where the environment is prod. That is also we can do. So instead of v dot environment after the colon, we can use the k. So it will output, and then we put the condition if v dot environment is equal to prod. So whatever the prod environment we do have in our map variable, list out all the keys as a list. So if we have multiple prod environment, then it will generate a list of all the NSG name like NSG1, NSG4 is also prod for an assumption. So NSG5 is also prod. So then it will list out the NSG1, 4 and 5 because if condition is checking if the environment is prod. So that is something you can do by your own and see if those things are working, and also do the practice with the multiple if condition like v dot environment is prod, and then there is a special operator which you can use. I think it is double ampersand sign, and then you can define v dot environment is equal to and location is West Europe. So you can also filter out all the prod environment in a location West Europe should generate the name of the NSG. So output should be the name of the NSG which has the prod as an environment and location as a West Europe. So that is also you can do some practice with the for loop in that kind of a scenario. For now, it will just give me the Terraform plan output will give me NSG is equal to prod. In the last one, it listed out prod, dev, and test or 3, but here I have a condition and now it is just using the prod as in condition. So that was about the output of the list when I do have the like a different values. Okay, but there is one more scenario. If I wanted to transform the keys, transform to values, I want NSG1, NSG2 and NSG3 to should be value, and I want RG1 or the resource group should be key. So we can, with the help of the for loop, we can also make sure that we can make key as a value and value as a key. So let's try. So I wanted to do the transform key and value. So I know like now I need key and value both. That means my output should be in a curly braces, or my for loop should be inside the curly braces. So let's have a look. So now I do have a curly braces for k v in var.nsg, and now if you can see, the key should be v.rg and the value should be key, because I am just inverting it. I just wanted to make sure that value is k and the key is var.rg. Will it work? So let's have a look. If I run the Terraform plan, it will fail. Why? If you can see the error, it's a duplicate object key. Two different items produce the key rg1 in this for expression. Okay, why? Because we can see the rg1 is like 3 times, and we know that map can't have similar key or same key twice. The key should be unique in the map variable. So key should be always unique in the map variable. But in my case, if I am transforming the rg1, then it will be 3 times the rg1 in the key. So it will not generate it because there is a duplicate key, and Terraform doesn't support the duplicate key in the map variable in a key value pair. Otherwise, you will not be able to identify like which key has what value. So we basically can't have the duplicate key in the map variable, and with this for loop, we are trying to do the same. But what I want is, I know this RG1 is a same. So let's do one thing. Let's have one key, and the value should be the NSG1 and NSG2 and NSG3 all together. Let's group it, because I know like the RG1 have the same thing. So that means RG1 will be the key and value should be the list of NSG1 and NSG2 and NSG3. Can I do that? So yes, we can do that. And if you can see in the error as well, if duplicates are expected, use the ellipsis sign after the value expression to enable the grouping by key. So let's see how we can do that and what would be the output. So after the K, what you have to do is you have to use the 3 dot sign. So you have to put the dot thrice. What it will do is it will activate the grouping mode. So if we are activating the group mode, that means if it will find the duplicate key, it will group it. The for loop will group the duplicate keys. In my case, the duplicate key is RG1, RG1 and RG1. So let's see what would be the output. And my output is RG1 is equal to list of NSG1, NSG2 and NSG3. So it has activated the grouping mode. That means if the for loop find the duplicate key, and we know map doesn't support the duplicate key, so what it will do is it will group the value, because RG1 has the same NSG1, NSG2 and NSG3. So with the help of this 3 sign, you can do the activating the grouping mode and it will group it in case if you need it. If you don't need it, then let's not make it complicated. So that's all about the for loop. I hope I tried my best to like show how for loop is working, and I tried my best to let you guys know like how the things working with the for loop, and hope you understand it. If you don't, if you have any question, then you can always put it into the chat or in the comment of my video, and then I'll try to make sure that I can answer it as soon as possible. But for loop is basically a difficult one, but it is very helpful. In some cases it was very helpful in my production environment. I used it not a lot, I'll not say it a lot, but wherever I need it. There were some scenarios where I used it, and there were some multiple looping condition where I can't use the for loop alone, or for each loop alone. Then I had to use the for itself and transform the value and generate a map variable in a way which I wanted. So for loop is very helpful in that kind of a scenario. I hope you guys got what I was trying to show you. And yeah, that's all about the for loop. And in the next one, we are going to see in a practical way how the for loop is using, and I'll show you some practical example real-time scenarios where I use the for loop and why I use the for loop, and instead of like any other grouping and making the thing complex with the for loop. Okay, that's all. Let's have a look to the practical way. So in this topic, we talked about the for loop. But before we are going to discuss about the for loop, I wanted to let you know that I made some changes into our code. If you remember, when we started writing the code, we have this network security blocks for the network security groups, and then we had this virtual network and the subnets. Take the screenshot of this code, and then I'm going to show you what changes I have done. Basically, that is with the leveraging the for each loop. I totally converted this code into some new way which is more flexible to write. I made those changes. You take the screenshot of this one and compare with the another code which I have written or updated with the using the for each loop, make it more simplified, and then see like how or what changes I have done and try to understand it. So it will give you some insights or more insights about the for each group. For each group. So that was our old code. I'm gonna remove this code because I already updated and created a new code in the network.tf file. And now you can see we do have this virtual network block and we don't have the subnets underneath of that. Instead of that, we do have the subnet block itself. So Terraform does have the separate block for the subnet. So either you can use the sub resources in the virtual network itself, or you can have the separate block for the subnet. Then we do have the network security group, and then we do have the network security group association block to link the subnet with the NSG. Take the screenshot of this code and also the terraform.tf was for the subnet and see what changes I have done using the for each loop and how simplified it would be going forward. So now if you can see this subnet block, we can just define the number of subnets or whatever the subnets you want, you can define in the variable itself, the same thing which we did with the databases. Try to understand it. If you have any question, just put it into the comment and I'll try to answer it as soon as possible. And now let's talk about the for loop. For the for loop, we are gonna deploy a few more resources as we have to complete this project. So I think we already deployed the virtual network, we deployed the subnet, we deployed the NSG, and we also deployed the databases. The next thing which we have to deploy is the app services. That is again like the important part of the project. So to deploy the app services, what we are going to do is we are going to take again the references from the Terraform documentation, and we do have the Linux. So we are going to use this Linux web app. If you have the Windows, then you can use the Windows web app resource block for the app services. For the app services, we know we need the app service plan. So we are going to have the app service plan and then the app services. I'm going to take the, going to copy it, create a new file just to keep it simplified. Use the compute.tf because it's a compute resources. And then I'll go my resource inventory to copy the naming convention. So for the app service plan, I do have this naming convention. I'm going to copy it here and I'll just put it app service plan. And for the resource group, I know the name of the resource group is this one. Same thing I'm gonna copy into the app services, and this is the ASP. So I'm gonna update the reference here because in the app service we have to pass the app service plan ID. So the service plan ID I have passed it here. The naming convention, again, I wanted to create the portal platform data. So I have to create 3 app services. I'm gonna utilize the same for each group again. But before that, let me just update few more things here in the naming convention of the app service plan. That is var.environment, and then we do have this var.location short. Okay, app service plan looks good to me. I don't have to make any further changes. The Linux type will be the OS type will be the Linux, and the SKU I wanted to use the P1 V2 itself, but you can define whatever you want. And as per the project, I wanted to use the P1 V2, so I'm going to use this one. App services, I'm gonna use just app services. And for the app services, what I need is, apart from this configuration, I also have the app settings. And app settings is basically a key value pair, if you can see here. App setting is one of the configuration we do have in the app services. Now the requirement I do have is, the first thing which I'm gonna do is, I'm gonna create or declare a variable called app services. Then I'm gonna define and the value of the variable in a way it would be more easy to deploy, similar to the subnets in the databases. So let me take the app services as a variable. Now, similar to the subnet in the databases, I'm going to use the key as a name. So the first resource which we do have is the port, and then we have plat and data. So plat is platform, port is portal, and then data. So key would be this one. And if I go to the configuration of the app services, I don't have to define anything else, just the naming convention here. So I'm gonna copy the naming convention from here, app, and this is my naming convention of the app services, right? And also I have to define the app settings. Now, the main use of the for loop is going to be here. The app settings, which is something we are going to pass here in the variable, it would be app settings and then the key value pair, because app settings is the key value pair. So let's assume we have to take the input of the app settings as a version, and one of the key is version. Then we do have something like log info or something like that, and then the log info should be the info that is just for the logging. And there is one more called maybe, oh, we can just take two of them for now. But the requirement I do have is, or my application's requirement is, the variable or the app settings which I'm going to pass, that app settings is basically should have the environment name in front of it. So here we can pass the version and log info, but in the app services, it should be the environment name in capital and then capital version and something like this, because the app setting is going to be in an environment variable format to the app services. And my requirement is on the application that there should be an environment name. Based on that environment name, there are some parameters in my application which is going to be defined. So the app settings key value I'm going to pass, I want it should be prefixed with the PRD, it should be in uppercase, and then it should be added as a app settings. Okay, and we know we wanted to make the code environment flexible. Like if I'm passing the prod, then only the prod should be added, and I'm passing the test, then the test should be added into the version. So that is my requirement. For now, I have defined this port. Then similarly, I can define for the data and the platform. So the next one is the platform and then data. For platform, the name is plat, version is same, login for is same, and for the third one we do have is the data. I'll just copy it here, paste, and then the data. And I need all these app settings, and there might be more, but for now I'm just taking the example of these app settings. So I have this variable. I'm going to use the for each here in the Linux web app. So I'm going to use it for .app services, and the name I know that it will be the each.key, as we have used with another one with the database and the subnet. Let me replace the environment too. Okay. Now, so far everything looks good except the app settings plan, because I can use the app settings here in the compute, something like this, each.value.app settings, something like this, right? Because we do have each.value.app settings. But my requirement is to transform the variable, the value which I do have in the app settings, with the requirement, like there should be an environment name with the key of the app settings. So what I'm going to do here is I'm going to use the for loop here, and let's see how we can use it. The first of all, what I'm going to do is the output should be in a map itself, because I want app settings to be in a map output. So the first thing which I'm going to do is use the output format. So as I have already explained in the for loop, whatever the braces you are going to use, the output of your for loop would be in a same way. So I want in a key value format the output, so that I'm going to use the curly braces. Then I'm going to use the for key value in each dot value dot app settings. What does that mean? That means I'm gonna extract this information here. So this each dot value dot app setting is this portion. for every app services, for portal, for data, and for platform. And I wanted to transform this value. So let's do the transformation. First, I took that value. Now I have to transform it. The output which I want, I'll have to define with the colon, and the output which I want, I'm gonna define here. So now the K here in the app setting is this, and value here is this. V is representing each value, info 1.0 and all, every time with every group. Version is K. What I want is, I wanted to use the environment name, var.environment, right? This is my environment, and also in a upper format, because generally my environment is in a lower case, but I wanted to use in a upper format. So what I can do is I can use the function. That is the first thing. So the environment, and then I want a hyphen on top of that, and then I want the key value, key. So I can use the key, but not directly. Again, it's a variable, right? So it should come with the interpolation. Now what would happen? All the key values, all the key here will be append with the environment in upper format, and even k can also be in a upper. So get it before now. Otherwise, we can use the upper format in other way as well, like do the complete and then the upper. Right? Let's do it that way. I'm gonna use this var.environment. I'm gonna use something like this, and then because I want all of them in upper, so I can probably use something like this. And then the value should be the value which I want should be. Let me check. Yeah, it should be like this. Yeah, sometimes it's a little bit confusing. So now it looks good. We do have upper. Before that, yeah, I want environment hyphen, and then I want key, like every key. And then once it is prefixed, then convert it into the upper. Okay, so that is I want. Like my environment, this should be environment hyphen version is equal to 1.0. So I don't want to change anything into the value. So what I'm going to do is I'm going to keep the value. So we are representing it with this. The value should be representing it this. When we took this curly braces, that means we need an output in a key value format because we want an output in a map. So the output should be in a key value format. For k and v in each.value.app setting, for every k and v, for every key and value in the app settings should be transformed into adding the environment, making it upper, and v I just wanted to keep it same because I don't want to change the value. So I wanted to keep the value as the same. If I wanted to do something with the value, like changing it with the upper or something like that, that is also I can do. But I don't want to do anything with my value for now. So I'm just going to put the value as a value. So the part here is representing the key, and the part after this particular arrow will be the value. So let's see if it worked or not. Technically it should be. Let me just quickly save and run the Terraform plan. So for loop is basically, I already explained it, but let me tell you, the for loop is basically for the transformation. If I want like all the values as a list, that is also I can do. Instead of using this, I'm going to use the square braces and for k comma v in this, and then after the colon, I just have to define the v itself. Okay, so the plan is executed. That means it was success. Now let's have a look if we do have the app settings in a required format or not. So I'm gonna do it, go it up, and I can see tst-log_info, tst-version, and info, and then version. So if I go to the terraform.tf files, what I use is log info is info. That looks good, and my values are also transformed. For version, it is tst-version, and the version is 1.0. Similarly, it goes for all of them. If I'm going to change the value, let's assume for the platform I'm using 1.5 version. For portal, I'm using 1.0, and the log info is critical. Just wanted to make sure my all the looping is working fine. And then verbose, and this is 1.2.0. Let me run the Terraform plan again. So for portal, the app setting should be 1.0 and critical, 1.5 and info, 2.0 and the verbose for the data. So once the plan is executed, we are going to have a look if my transformation with the for loop is working fine or not. So basically with the for loop, I have transformed the value in a format which I want. And there are a lot of use cases of this for loop. It is definitely going to make your code more complex, but this is very helpful for the dynamic execution or dynamic requirement if you have something. So let's have a look. For portal, let's go to the Terraform TFRs. For the portal, I want 1.0 and critical, looks good. For platform, I want 1.5 and info, that also looks good. For data, I wanted to use verbose and the 2.0. And let's assume if I have any further value, like test is equal to ABC, then the test will also be added, or like testing phase or something like that. And then that is also be going to be transformed. So this is how we are gonna use the, I'm gonna save it and I'll just apply it. So it will be, the app services will be deployed. So now if you see, with the help of the for each loop, our code is very simplified. We don't have to touch the compute again and again. If I wanted to introduce a new app service, I can just simply come to the Terraform TFRs and I can provide all the information. So now you can see with all this conditional expression and the expressions we do have in the Terraform, we can make our code more flexible, right? And more user friendly from the front end. Maybe the compute.tf and the database.tf file is very complex to understand with all this for each and the for loop, but the the actual thing in the Terraform TF is very simple. We can just pass the value and it will be applied there. And we don't have to change the main code again and again. So this is how the for each and the for loop works. I hope you understand it. If you don't, if you have any question, you can always put it into the comment and I'll try to answer it as soon as possible. Hope you enjoyed this session and I'll see you in the next one. Thanks for watching. Let's discuss about the dynamic block now. Dynamic block is basically another type of a Terraform expression. So far we had a look like we can use the for loop, we can use the for each loop and the count loop. All this loop was working on a resource block level, or some of them can work with the data source block as well. But dynamic block work in a different way. If you still remember the resource block overview when we were discussing about the resource block topic, there was a sub block or nested block we can call. This sub block or the nested block are not coming up with like every resource. It depends on a different resource type. Like it doesn't come up with the resource group, but it does come up with the Azure route table or the virtual network. So with the help of the dynamic block, we can assign the value of this sub block or the nested block dynamically. And there are multiple resources in Azure which does have this kind of sub blocks or the nested blocks, and we can assign them multiple times. In some cases, we can assign only one time. So let's talk about this Azure route table itself. We can define multiple routes in a route table. So in that scenario, this route block underneath of the Azure route table resource block, we can assign multiple time. Now we wanted to do the looping and iteration again, but this time not on the resource block level, but on this sub block or the nested block level. How we can do that? This is what we are going to discuss about in this dynamic block topic. So let's have a look. I'll show you some example where and how we can use the dynamic block. And there are basically two types of the dynamic block usage, I would say. Then let's have a look how we are using and what is the purpose of the dynamic block in those cases. So let's take an example. We do have a resource block of virtual network, and if you already worked on the virtual network resource block, or if you go to the documentation, Terraform documentation for the Azure RM virtual network, you can see we can have this repeatable nested block in the Azure virtual network where we can define multiple subnets, because we know like when we are creating the virtual network, we can have multiple subnets underneath of the virtual network. So that means we can use this sub block or the nested block multiple times, and we can have this subnet and then name and address prefix and whatever other values we can configure on the subnet level itself. So we can have those kind of a value over here in the subblock. But for now, the required values are the name and the address prefix, and we can have it multiple times. So I can create subnet 1, subnet 2, subnet 3. So far we had a look about the for each loop, and we can use the for each loop on the virtual network or the resource block level itself. What we could do in this kind of a scenario where we do have multiple nested blocks or the sub blocks. So we can use the dynamic block Terraform expression over here to do the iteration underneath of the resource block itself. So the resource block itself will be executed only once, but the sub block or the nested block under the resource block will be executed multiple times with the help of the dynamic block. So if I take the example, the same example of a virtual network, and I wanted to do the multiple subnet creation, but instead of like writing this subnet nested block multiple times, I would like to use the for each loop, what we use with the resource block. So let's have a look with the help of the dynamic block, how we can use it and what we will have to configure. So the first thing what we will have to do is similar to the previous section which we discussed about the for each loop. This thing is also something we can configure with the map variable. So let's move the values into the map variable first. So let's assume I do have a subnet's local variable where I can have the key value pair of the subnet 1, subnet 2 and subnet 3 and can assign the value of the address prefix for this subnets. So this is my local variable now. And now I want only the sub block or nested block should be iterated on this variable, not the whole resource block, because I don't want to create multiple virtual network, but I wanted to create multiple subnet underneath of that virtual network. So let's have a look how can I achieve this with the help of the dynamic block. So first I'll move these values into the local variable. That is the first thing I'm gonna do. Or I'll create a variable where I can have the values assigned. Then let's take an example of the virtual network resource block. We have written name, resource group, name, location, address space prefix, and now we wanted to do the dynamic blocking on the subnet level. So the very first thing which we will have to do is we have to write the dynamic and subnet block. And in this case, in this virtual network case, the subnet block is repeatable. But in some cases or in some resource block level, we have this nested block, but we can assign only once. And we'll see that example in the after this one. So how we are handling those scenarios. But in the subnet level where we can have the multiple repeated block or nested block, then first thing we have to write the dynamic space, then the block name itself. So which block we wanted to dynamically select, the subnet block, opening curly braces, closing it, then I wanted to do for each group on this block level. So what I'll have to do is I'll have to use the meta argument for each is equal to local.subnet, similar what we did in the resource block level, but now we are doing underneath of the nested block. And that nested block we have defined as a dynamic nested block, right? Second thing which we will have to do here is, which is a little bit different what we did in the resource block level for the for each, we have to define the iterator. So we'll have to write iterator is equal to item. So if you want, you can use the iterator is equal to item. Like when we were doing the for each on the resource block level, we were using the each dot key. But here in the dynamic block level, we can't use the each dot key. Instead of that, those each we have to replace with the iterator. So we can have the iterator is equal to item. And if you don't want to use iterator, then you can just remove the iterator and instead of the specific iterator, the subnet, the name of the block will be called as a iterator. But it's always good to use the iterator, so it will be a little bit easy to understand when we are reading the code. So the iterator is equal to item, and then here is the special thing which we have to configure for the dynamic block is the content. So whatever the value of subnet nested block we have to assign, like we have to assign the name of the subnet and the address prefix, it will go underneath of another block called content. So this is the way we are defining the dynamic block. First we are using dynamic, then the name of the block, opening curly braces, closing curly braces, underneath of those curly braces or that block, we are using for each loop, and for each is equal to local.subnet. Then we have to define iterator. So iterator will be the item, like I'll replace or I'll use item as a my iterator and I'll show how we are using it. And then we have to use the content. So in this particular content, we are gonna iterate. So let's see. The first content we have is the name because we have to provide the name of the subnet. And in my variable level, what is my subnet name, that is key. What I'll have to do is I'll have to use item dot key, not each dot key. Each dot key we are using on a resource block level for each. But on a dynamic block level, this is the difference. We can't use the each dot key. And I always keep doing this mistake because whenever I'm doing the for each, I always use the each dot key and then it is not working. Of course, it will not work because this is not the way dynamic block works. That is each dot key we can use with the resource block level for each. But on the dynamic block level for each, we have to use the iterator. And if you are not using iterator explicitly, then you can use the name of the block. So in that case, it will be subnet dot key. But as of now, we are using iterator and it's always a good practice to use the iterator. Then it will be item dot key and then address prefix will be same item dot value. So this is our dynamic block level. This is our loop over. This is our iterator to represent current element and that is optional. And then we do have content, basically the nested block content. So in our nested block, whatever the content we have, whatever the argument value we have to assign, we have to use it into the content block. And let's have a look now. So this would be my resource block with dynamic block for my nested subblock or sub nested block. Now let's run the Terraform plan command and you can see it will iterate over the subnet block and it will create three subnets, subnet 1, 2 and 3, and whatever the value I have assigned, it will be created over there. So this is how we are using the dynamic block. So dynamic block basically we are using with the nested block or the sub block in underneath of the resource block. So if we have any resource which comes up with the nested block, we can use the value dynamically. But you have to choose if that block can be repeatable or not. So in some cases it is repeatable like this one. The subnet block can be assigned multiple times. So we can use the for each loop and we can assign the value multiple times. The one thing we need to keep in our mind is dynamic block will always work with a for each. If you want to use count, then it will not work. There is a workaround and I'm going to show you what workaround we can use. But dynamic block will always work with the for each only. You can't use any other loop or iteration with the dynamic block. So this is the only way we can use the dynamic block. And that is the special case. So that's why we have to use the iterator and then do the item dot key and have this content block. So for the dynamic block, the first thing we have to do is we have to write the dynamic in front of our nested block. Then we have to use the for each loop and whatever the variable we do have, we can assign that variable for our for each iteration. Then we have to assign a iterator. If you want, you can like avoid it and you can use subnet as your default iterator. So that is optional. And then in the content, whatever the content your nested block has, you have to assign the value over there and you have to use the iterator instead of the each. So it will be item.key and item.value. And when you run the Terraform plan or apply, the iteration will be happen on your sub block or the nested block itself. So this is how the dynamic block works. Let's have a look to the another example of dynamic block. Let's assume I have to create a SQL server. And I know in the SQL server, there is a sub block called identity. Identity is basically creating a managed identity of my SQL server. And I know this identity can only once, or this block can be defined only once. It's a non-repeatable, unlike the subnet. I can assign only once. If I'm assigning another one, then my Terraform syntax error will be there. It will not even validate. You can't even do the Terraform validate with that because it is not possible. So identity block is just one block and we can't repeat it. That means with the for each, we are repeating the block. But if it is a non-repeatable block, then what can we do with the dynamic block? Because we know with the dynamic, we have to use the for each. So there is a scenario. I do have this variable called manage identity enabled. So this is basically a use case which we do with the dynamic block. And as per the description of the variable, if this variable is set to true, because its a type is equal to Boolean, then the managed identity of the SQL server will be created. If it is false, then it will not be created. And default is false. So now let's have a look based on the value of this variable, how we can either enable the identity or disable it. So enabling, that means this block should be there. When I'm creating SQL server, if this block is there, then that means the managed identity will be created. If this block is not there, that means the managed identity will not be created. So now I have to assign the value of this variable, and based on the assignment, this block should dynamically work. It should be either enabled or disabled. That means either this block should be there or should not be there based on the value I am assigning to this particular variable. So what does that mean? That means this non-repeatable block, either it can be 0 or 1. Like it will iterate either 0, that means the block is not there at all, or it will iterate only once. That means the block will be there. So if enabled, then the block should be there. If disabled, then the block should not be there. With the help of the dynamic block, how can I achieve this kind of a scenario? And that is actually a production level use case, I would say, because I'm using in my environment, in my production environment. So let's have a look. How can we assign this kind of a scenario with the dynamic block, or handle this kind of a scenario with the dynamic block? Let's have a look. So in that case, what we will have to do is, first we will have to define the dynamic block, similar to the last example which we discussed, dynamic and then the block name, right? Now this is a special thing here. So now the for each will be var.managed identity is equal to true, and then the question mark, and we have colon. That means this particular section is a if condition. What it is? It's a if condition. That means var.managed identity enable is equal to true. If this value is true, then what would be the output? 1. That means this block should iterate once. This is what I want. If it is true, then this block should be enabled or iterate, or should be there. If it is false, that means it should be an empty list. Empty list, that means there is no value underneath of the list. That means it will not iterate at all. So it's a blank list. Blank list, that means there is no value. There is nothing to iterate. That means it will not iterate at all. So with this, with the help of this condition, we can assign the value of var.managed identity. Okay, and then var.managed identity will decide if the identity block should be there or not. So let's have a look. Then again content, and we know content is fixed, so we don't have to make any changes over here. We can use the type is equal to system assign. So that means if the value of the var.managed identity enable is equal to true, for each loop will iterate once, and if it is false, then the empty list will be taking into the consideration, and the for each loop will not iterate at all. So let's have a look. If I run the Terraform plan command, and if I assign the value is equal to true, then there will be a block of identity. And we can see then create system assigned managed identity. So if the value is true, then create the system assigned managed identity. If the value is false, then there is no identity block at all. That means if we have a non-repeatable nested block and we wanted to handle it dynamically based on some user input or some variable input or some output of some resource block or something like that, then we can assign it dynamically with the help of the dynamic block. So we have basically two scenarios where we are using the dynamic block. One where we do have a repeatable nested block like subnet. So we can use the for each loop and we can iterate it again and again based on the math variable which we do have. Or the second scenario, we can have some conditions, and based on that, the non-repeatable nested block should be there or not, we can decide dynamically with the help of the dynamic block. So let's have a look to the dynamic block in a practical way. I will show you a couple of more examples, and I will show you how we are using it into the production environment and how it helps us to like do the things dynamically on the nested block level. So let's have a look. In this section, we talked about the dynamic loop. Let me show you how we can utilize the dynamic loop. First of all, let's discuss what is remaining in our project. So we have deployed the app services, we have deployed the databases, we have deployed the virtual networks, subnets, network security groups. The only part which is remaining in the spoke, I'm not talking about the hub, because in hub we still have the DNS and the VPN gateway and the application gateway. But in the spoke, we have one thing remaining, that is the security rule. So we deployed the network security group, but we did not deploy the rule so far. Though we have already configured it into the variable, like this is the format I want, right? I wanted to provide the subnet and the allowed ports, which I need on the subnet, right? So now let's have a look how we can utilize the dynamic block to iterate over this allowed ports value and create the network security group as an inbound allow. So let's have a look. The first thing we have to see how we can utilize or how we can create the network security group rules. So we have this network security group block, and if you go to the Terraform documentation, in the network security group block, you can also use the security rule block. That is the one way of creating the rule, and the another way is you have a separate block as well for the network security group rules. But in our case, we don't want the separate block. We can utilize this one. And now, if you see this particular security rule block, it's a sub-resource block, right? And we already discussed about it. Dynamic group can only be used with the sub-resource block of the resource block. And this is what we do have right now here. And we can utilize the dynamic block with the security rule. Now, if we see in the security rule, we have a couple of arguments. And from input, we just wanted to take the port as an input. Not all this information like what would be the protocol, because most of the time the protocol is the TCP, or we can use the any protocol. Source port ranges will be star because we are not going to filter on the source port, but we are going to filter on the destination port. Source address prefix should be any, destination should be any. This is what I want. I just wanted to allow and keep it simple as a port. So every traffic coming to this port should be allowed. That is what I want. And it should be inbound traffic. It should be allowed. Priority I'll have to change, and name I'll have to change, and the destination port I'll have to change. So I need 3 inputs from here, or 3 inputs I'll have to provide in the security rule. But as an input in the variable, I'm taking only one, that is the port. So I have to construct in a way that dynamic loop will reiterate or iterate over the list of the allowed ports, whatever the values I have, like I have 5 ports allowed in a allowed list here. Terraform.tfs, if I have provided like maybe 1434, something like that, or 80, comma, whatever the ports I'm gonna allow. What dynamic group should do, it should take each port every time, create a security rule for that. Then take the another one, then create another security rule. This is what I want. Okay. How we are gonna do this, or how can we achieve it with the help of the dynamic group? So let's have a look. First thing first, we have to copy this security rule so we can know what informations we have to provide it. In the network security group, we are already iterating over the subnets. So we are already iterating on each subnet, and now we have to iterate more on the allowed ports as well, right? So let's see how we can define it. So first of all, I'm going to take the security rule, do the quick Terraform it, and yeah, it will just arrange it. Now I'll have to use the dynamic group. So as I have mentioned in the description, or when I was explaining the dynamic group, the first thing we have to do is the typing dynamic, and then we can use the security rule, or you can also put into the inverted comma without inverted comma. That is the first thing. Like this block I want in a dynamic. Before I'm going to explain you how we are going to do it. I already explained that in the Azure provider, we do have sub-resource block of 2 types. One is the repeatable, and some sub-resource block are not repeatable. You can define only once. So you will have to make sure that you are using the correct sub-resources or sub-resource block to iterate over. So security rule is something because we can create multiple rule in the NSG. So that sub-resource block is repeatable. We can have multiple sub-resource block in the resource block. So if I'm just gonna change it, if I copy it and paste it again, then it is acceptable. I can create multiple times, but some resource block you can't have the sub-resource block, you can't have multiple times. So if you wanted to use the dynamic group, you can have only one sub-resource block, and which I have explained, like if you have condition that Azure AD authentication should be enabled or not, then that particular sub-resource block should be executed or not. So for those kind of a sub-resource block, which is only one, or you can define only one time, you can have the condition you want to define or not. And if you want to define, then you can put the dynamic group based on that. But in our case, we wanted to do it like multiple times based on each port. The security sub resource block should be executed. So I'm going to put the dynamic here. I can do something like this. The next thing which I'll have to do is I'll have to put all this arguments into the content, and this is my content, first, second, and I guess first, second. Yeah, that is fine. Now we have to put the condition. So I'm gonna put condition. What should be the condition? So condition is I wanted to iterate over these allowed ports. We are already iterating over the subnets. So technically the condition should be each dot value because we are using subnets. So we wanted to iterate on each subnets and furthermore on each allowed ports of each subnet. So it should be each dot value dot allowed ports. Okay, so it will be iterated over the allowed port, and this whole block will be iterated over the subnets. Like the resource block itself is iterating over the subnets, and then this dynamic block is furthermore iterating on each allowed ports. Okay, so that is the first thing we have to do. Second thing, we can define the iterator, and I wanted to put iterator as a port because we are gonna put it on each port. That is the first thing we have to do, and I'm missing one curly braces here. Let me quickly do the Terraform formatting. Okay, yeah, that looks good. Now, what I want is, right, I want the port to be used as a destination port. So what I'm going to use here is the iterator port dot value. For the each port, there should be a new rule, and that is what my dynamic block is going to do. So let's run the Terraform plan, and then we'll have a look how it behaves. I already saved it, and meanwhile, let me explain it again. So we want security rule sub resource block as a dynamic block. We want to iterate it on each subnet's allowed port. So we have 3 subnets and then we do have allowed ports. So we have total 2, 2, 4 and 5. 5 allowed ports and 3 subnets. So technically my loop should execute it 5 times for each allowed port and for each subnet. So for first subnet it will be executed 1 time. For second subnet it will be executed 2 times because we have 2 ports. And then for third one, we again have 2 ports, so it will be executed 2 times. So 5 resources should be added, but we have the security rule. We already deployed the network security group and all. So let's have a look how it behaves, and then I'm going to show you what other values we have to update because priority can't be same for 2 rules, and we have more than 1 rules for the port. So the priority should be updated as well. I'm going to show you how we are going to update it, and the name should also be updated. These 3 values we have to update. Okay, I can see 3 changes. And let me just expand it. Okay, that looks promising to me. For the backend, I have port 80 and 443, so I can see destination port 443 and I have destination port 80. That is what I want. For the DB, I have only one port, that is 1433. For the front end, I have again 2 ports, 443 and the 80. That means my dynamic group is working as expected. Total 5 ports are going to be added into the allowed rules. But this run executed successfully, but the apply will not work here. Why? Because for both these rules, 443 and the 80, we have the same priority. And you can't have the rule with the same priority in Azure, right? So that is something is not going to fail on the plan, but it is going to be failed on the apply side. So now we have to update the priority, but I don't know what should be the priority, and I want like which every port the priority should be updated as well dynamically. So I want to like first of all, I wanted to use 200 instead of the 100 because 100 is the last one. And for each port, like I have 2 ports. So I want this port should go to the lower priority. So that would be the 201. And this port should be going to the higher priority. So 443 should be on up and port 80 should be on downside. And we know like the race number, the port would be on higher priority. So I want this one to be 201 and this one to be 202. How I can define it? I can find the index value of this list and find accordingly. And for that purpose, what I'm going to do is 200 plus what I'm going to use here is the index function. And for the index function, what we have to do is we have to define the list and the value for which you wanted to find the index. So for me, let me put the index first. And what do I have is a list, the whole list. So the whole list is the allowed ports, right? This is the whole list. Okay. And what index or what value you wanted to find, like for index. So I want to find index for the port dot value. So port dot value is 80 or 443. First time it will be 443 and then the next time it will be 80 because we are iterating over it. This is what I want. That is the first thing. Second thing, I wanted to update the name. So I'll put something like allow port hyphen port dot value. This is what I want. So the name of the security rule is also be going to change based on the name of the port. Let me run the Terraform plan again and let's see how it is behaving now. And meanwhile, the plan is executing. We just quickly go to the network security group and see what rules we do have so far. Not in the portal, but here. So I do have this default rules. I wanted to allow the port 80 and 443. So once I'm going to apply it, the rules should be here. So let's see. And this is how we can utilize the dynamic block. Dynamic block can iterate over the sub resource block itself. Okay. Allow port, the name looks good. And the priority is 201 and 200 port 443. So this is what I want. 443 should be 200 and then the 201. Let me just quickly apply it so we can see the output of the dynamic block. And this is basically how you can use the dynamic block. And that is the dynamic block is very helpful to make your code more dynamic when you are using this kind of a scenarios. So if you can see, if I wanted to like write down the security rule block itself, and if I have like maybe 10 or 20 ports to be allowed, then how difficult it would be to write the code and how like complex your code would be. And if you have to make any changes, then it will be very difficult for you to find the code, then update the code, and it will not be very manageable, I would say, or easy to manage. But with this dynamic block, you can just simply define like going forward, I wanted to allow any more ports, like on the DB, I wanted to allow 1434 as well, or something like that. Some dynamic port like 509, 59802 or something like that. I can just simply add the port here in the variable and run the Terraform apply, and based on my dynamic block, the port will be automatically added. So with the dynamic block, your code will be more easy to update or easy to modify. Okay, 3 changes are completed. Let me go to the portal and refresh it. Nice. I can see I want port 443 to be on top, and it is on top, and port 80 is on the 201 priority, and that is allowed. Any TCP in the allowed. If I wanted to change the protocol, that is also I can do. That was on the front end, oh sorry, back end. Now let's have a look to the database. Yes, port 1433 is allowed. Nice. And the last one is the front end. I can just quickly go inbound security rule, and the same ports are allowed on the front end as well. That's all what we have to do in the dynamic block to iterate over the like any list or any map with the help of the for each and the dynamic block. So you can just simply write your code and your network security block is ready with all the rules and everything. I hope you enjoyed this session, and if you have any question, you can put into the comment. And thanks for watching. I'll see you in the next one. So now let's discuss about the provisioner. What is provisioner in Terraform? So provisioner is again another type of the Terraform expression which help us to run any kind of a script either locally or remotely. So we do have like multiple options to configure the provisioner. We can run the script locally, we can run the script remotely to the virtual machine which we are creating through the Terraform. We can decide when we wanted to run this script at the time of creation or at the time of the destroy. So we can also decide, or we can also configure the provisioner in a way when the resource is getting destroyed, then only this script should be executed. We do have multiple interpreter which we can use to execute the script. So we can use the command prompt script, we can run the shell script, we can run the PowerShell script, or we can also run the Python script with the help of the provisioner. So let's have a look what we could do with the provisioner. I'll show you a couple of type of examples like how the local executioner provisioner works and how the remote executioner provisioner works. So let's have a look over here. Let's assume there is a scenario. First, like the type of the provisioner is local executioner and remote, as I have mentioned earlier. The provisioner can be local executioner if you wanted to run the script locally. And when I say locally, that means where you are running the Terraform plan or the apply command, where you are running the Terraform configuration code or executing the code. And remotely, that means you can run the script remotely, whatever the script you want, and you can provide all the information about the remote path or remote location, and then it can be executed remotely from the Terraform itself. So let's have a look to the local executioner first. Let's assume I do have this virtual network resource block and I wanted to generate some log. Like whenever this virtual network is getting created, I wanted to generate a log file in my machine or wherever I'm running this Terraform code. And I should have the virtual network ID stored into the log. So I can have the information like when it was created and what is the ID or whatever I want. But for now, I just wanted a virtual network ID. It should be stored into the text file as soon as the virtual network is getting created. How can I achieve it with the help of the provisioner? What I'll have to do is, the provisioner is again a meta argument. So we can just simply extend our resource block. We can use the provisioner, but this time the provisioner, and then we have to define the type of the provisioner. So in that case, I just wanted to generate the logs locally. I don't want to do it remotely. So what I can do is I can use the local executioner. And then I'll have to open a curly braces and the closing curly braces. Then the first thing I'll have to define is the interpreter. What kind of a script you are going to execute. So just for the simple or just for this example, I'm using the PowerShell to generate the log, to generate the text file. So my interpreter would be the PowerShell. I can use the CMD, I can use the shell, I can also use the Python, but that should be installed on my machine. And if I'm using a Windows machine, then the shell wouldn't be there. So that time I can't use the shell. So you have to make sure that whatever the interpreter you're using, it should be installed on the machine or the local machine itself. So in my case, it is a PowerShell and PowerShell is already installed on the Windows machine. So I'm using the PowerShell. Then I'll use the command and my command is write hyphen I output, which is basically a generating output. And then I can use vnet id and self.id. Self.id we can use inside the resource block itself. So what it would do is it will generate the ID and will use the self ID and will put it into the vnet log file. So this is my PowerShell script, just one line of PowerShell script. If you have a PowerShell script itself, like a whole PowerShell script, then you can use that script also. And you can use the Terraform parameters, output references into that script. Maybe as a parameter or as a passing variable. So that is also can be done. Then you have to make sure that you have the PowerShell script inside the same folder, or otherwise you have to pass the folder path of the PowerShell script. So in any ways, in my case, I just wanted a one-liner script that is write the output, and in the output, I'm using the Terraform output. I'm using the Terraform output in my script, so I can have the reference inside my script. That is the main thing or that is the main benefit we have with the provisioner. We can run the PowerShell script like if we have the pipeline, then we can run the Terraform, and then after that we can run the pipeline and the script whatever we want. But then we'll not be able to reference or get the reference from the Terraform from inside the Terraform. But with the help of the provisioner, you have all the variable, all the resource block, data block, output can be accessible here. Like what I'm using right now is the save.id. I can also use save.name, save.resource group name, save.address space, or I can also have the reference of any other resource like Azure RM underscore resource group underscore and dot RG1 or something like that. That is also I can define. So with the help of the provisioner, I can have the access of all the inside Terraform variables. So with the help of the local executioner, we can run the PowerShell script locally. The next one would be the working directory. We have to define where it should be stored or where it should be written this vnet.log. So I wanted to return it into the ctemp. And I'm using double backslash because in the Terraform, if you're writing a path, then you always have to use the double backslash. Because on the Terraform is written into the Golang, I believe, and Golang have this escape character. So I'm not gonna go into it, but yeah, in short, if you're using a backslash, then you always have to use twice, like double the time. And then you can use the quiet is equal to false. Like if you don't want to show it into the Terraform plan or the out apply, then you can use the quiet is equal to true, then the output or the execution will not be in our Terraform plan or the apply. So that is also can be done. And this is the important one, when you want to run this provisioner. So I wanted to run at the time of creating the virtual network or at the time of creation of this resource block. If I wanted to do on the destroy, then I can use when is equal to destroy. So we can either run this executioner on at the time of the creation or the destroy. So this is our local executioner for our provisioner. And then let's run the Terraform apply command and see what would be the output. So if you see here, provisioning with local executioner, and you can see the output. We have configured the quiet is equal to false. That's why we can see all these logs over here. If quiet is equal to true, then we wouldn't be able to see it. But we wanted to see, like, I just wanted to show you how it works. So you can see it was executed. And if I go to the ctemp, I can see vnet.log was generated. And if I open this file, I can see vnet id is equal to the ID what virtual network has when we are creating it through the Terraform. So this is basically a Azure resource ID which we do have for this virtual network. So this is what we could do with the provisioner. We can run the multiple script. Let's assume there are some scenarios where we have to run a specific script locally after creating the resource or after destroying the resource or something like that. So we can use the provisioner in that kind of a scenario. So that was all about the local executioner. Now let's have a look to the remote executioner. So I'm going to show you how we are writing the remote executioner, but I'll not be able to show you by running it because there was some issue from my local machine to the remote connectivity. So you can do that, but how we are doing, I'm going to show you. So with the remote executioner, let's assume I'm creating a virtual machine called VM1. I'll provide everything, all the properties and everything. And then I can use the provisioner instead of the local. Now I'll use the remote hyphen executioner. And this virtual machine, this VM1, this particular remote executioner is going to be executed on this virtual machine, which is going to be created over there. But then you have to make sure from wherever you are running the Terraform, it does have the network connectivity to this virtual machine, this newly created virtual machine. In my case, the virtual machine network connectivity was not there. That's why I was not able to execute it. But you can use the same reference and you can do it if you have the network connectivity between your virtual machine and this remote or where you are running the Terraform command. If you are using the pipeline and if you are using the self-hosted agent, then you have that connectivity. But in my case, it was not there. But let's have a look how we run the remote executioner. The first thing we have to do is we have to use the inline command and we have to use the echo remote provisioner test on VM, and then there will be a text file will be created. So we can use the inline for our command itself. Then the main thing which we will have to do with the remote executioner is the connection. This connection, we have to define every value to connect the virtual machine. So the first thing in the connection, we do have two type of connection. Either we can do the SSH if it's a Linux machine, or we can do the WinRM if it is a Windows machine. So we can use the WinRM if it is a Windows virtual machine. Then we have to define the username. We have to provide the password to authenticate the machine. We have to provide the self IP address like host where you wanted to execute it. If you want to execute in some other virtual machine, that is also possible. So I'm creating VM1, but I wanted to execute a script to the VM2 or some centralized server for maybe so and so reason. So that is also can be done. But in the most of the cases, we are using it into the virtual machine itself, which we are creating. Maybe as a post script of a virtual machine creation, like joining the domain, run this script, install this and that thing. So that is also can be done. So in my case, I'm using self.public IP address. That means the public IP address of the virtual machine itself. Then timeout 5 minutes. In case if we are not able to communicate to that virtual machine, then it will be timed out in 5 minutes. Then the port, so by default the WinRM port is 5985, so we can use the port 5985. And in case if you are changing it or doing some other configuration, that is also possible. Then use NTLM, network level authentication mechanism, then it should be true. And the last one is insecure is equal to true, and that is how we can run the remote executioner with the help of the provisioner to a virtual machine which we are creating through the Terraform. So the connection block is something which connect the virtual machine and run the inline script which you are creating over here or you are running over there. So this is how we can use the provisioner. If I talk about the production environment, we have rarely used the provisioner. In my case, I believe I used once or twice, but we are generally avoiding this provisioner thing. We are trying to do the thing like if I wanted to run the remote PowerShell script, then I'm either using the custom script extension or I'm using some group policy or something else. But like if you don't have any other option, then you can use the provisioner. I just wanted to explain it because if you are going for the Terraform exam, then they will ask you, or if you are going for the interview, there might be possibility they will ask you about the provisioner. So we do have like two type of provisioner, local executioner and the remote executioner. If you want to run the script locally, then you can do the locally. Local executioner is somehow we are using remote. I barely use, but local executioner we were using in some cases when the Terraform was code was not ready for some services which Azure recently introduced, and we don't have the Terraform module for that. So that time we were using the PowerShell script to run those resources or to create those resources through the Terraform itself, just to make sure we are creating everything through the Terraform itself. So there were some like exceptional cases where we were using the local executioner and the remote executioner. Otherwise, I barely use the provisioner in my production environment. So that's all about the provisioner. The next topic which we are going to discuss is the null resources. Let's have a look what we could do with the null resource. Null resource and the provisioner are somehow interconnected. So let's have a look. Null resource is basically a type of a resource block. So if you are using the Azure or even if you are using the AWS, you can still use the null resource. Null resource is helping us to run the provisioner without tie it to any resource block or any resource. So far when we are discussing about the provisioner, we can see either we can use it with the resource block as a local executioner or we can do it with the remote executioner. But in both cases, we have to tie it with the resource block itself because provisioner is a sub block in the resource block. So let's assume I have a case where I don't want to deploy a resource, but I want to run some PowerShell script. So what I can do is I can use the null resource. Null resource is helping us to execute the script without deploying any resources. So as the name mentioned, null resource, that means there will not be any resource, but still we can use the provisioner. That's why I have said that null resource is tied with the provisioner itself, or they are interconnected. So let's assume I have a case where I wanted to run some PowerShell script without deploying any resource. So I can use the null resource in that case. And then underneath of the null resource, I can use the provisioner. I can have the local or the remote executioner. In my case, it's a local executioner where I wanted to like generate some Terraform logs or something like that. So I do have a command. I do have a working directory similar to the local executioner which we discussed. But this time we do have this executioner with the null resource, not with the virtual network like we discussed in the previous section. So null resource will execute this script without creating any resource. So let's have a look how it works. I run the Terraform apply command and you can see it will be created and that particular executioner has been executed and we can see there was a Terraform logs file was generated into this in the c/temp directory and the message which we are generating through the command we can see it over there. I'm using the timestamp function so I can see when it was executed. Right now let's have a look. Once it is executed, if I run the Terraform apply command again, then there will no execution at all. Why? Because null resource or this provisioner will be executed only once if we are not explicitly mentioning any trigger into it. So now let's have a look to the trigger of null resource, and that is the important part of the null resource. Let's assume a scenario where I wanted to run a PowerShell script if value of any variable is changing, or if some particular configuration in Terraform is getting changed, or output of a resource block is getting changed, or any kind of a scenario where I want if the variable value is getting changed or this particular variable key is getting changed, if it's a map variable, then this particular script, the executioner should be executed. This kind of a scenario can be fulfilled with the help of the null resource and if we are assigning a trigger. So in this example, when we saw we have executed once, the script was executed, but on the second run, there is no changes. That means the script was not executed again because I didn't define any trigger. So in that case, Terraform executed the null resource and now it has the value in the Terraform state file. So on the next run, it will not be executed. But I have a scenario where I want a trigger if the time is getting changed because I am writing a log in my example and I am writing a log based on the timestamp itself. So whenever the timestamp is getting changed, my log file should be added or appended. Okay, so what I want is I want to trigger this null resource with every change of the time. So now I can use a trigger block and I can use always run is equal to timestamp. So it's a null resource trigger. With the help of this null resource trigger, every time when we run the Terraform apply, it will just keep running. It will just keep replacing. And we can also do if we wanted to like based on some variable value change that is also can be done with the help of the trigger. But in my case, whenever the timestamp is getting changed, the null resource should be re-triggered. So in last time when I applied it, it was showing me that there is no infrastructure change. But now when I'm running it, I can see there is a change and it was added and destroyed. So it has been replaced again. And if I see my file, the log file, I can see there is a new line with a new timing. So that is how the null resources work. And if you wanted to like trigger the null resource with a local executioner based on some specific trigger, then you can assign it. So if there is some script, then which you want to trigger based on some changes happening into the Terraform, you can do with the help of the null resource and the provisioner. So that is all about the null resource and the provisioner. It's like we are very unlikely using it into the production environment, but there might be some cases that like, if I am not using that doesn't mean nobody is using it. The functionality is there. If you find a use case, if you don't find any other way, any other simpler way, then you can use the null resource and the local provisioner and the remote provisioner to execute your PowerShell script, Python script, or the command shell. So that is how we can use the null resource and the provisioner combined, and we can define the trigger and all this information, and we can do whatever the task we wanted to perform, we can perform it with the help of the null resource and the provisioner. So that's all about the resource and the provisioner. And with this topic, we are completing the Terraform expression topic itself. And in the next one, we are going to talk about the Terraform module. If you have any question, just put it into the comment section. And thanks for watching my videos. Thank you. See you in the next one.